You're not audible here.
No, I was not speaking earlier. Can you hear me now
Audible
properly?
to anyone else? Or is it a problem at my... Oh, wait. It's a problem at my end. Yeah, please. It's
Uh,
okay. It's okay.
no
No
worries.
problem. It's okay. Okay, so I guess all of you are here. Please join because we are having back-to-back people from overseas, and they are fantastic engineers. Those who are going to share their ideas with you, please be there. Please join as soon as possible. So I welcome you to the last day of the AICTE sponsored Atal FDP. And today we are having with us Mr. Aditya Mehta. He belongs from India and lives at Germany right now. It's becoming a little difficult to even pronounce Koblenz, right? Before joining T Systems, he finished his master's program in Web and Data Sciences from Koblenz University. At Germany itself, he has around 10 years of experience in modern software development techniques, including data, cloud, AI systems. He's an avid reader and spends majority of the time with nature as well as he loves traveling. And he tries to learn different languages, cultures, and build a second brain with the markdowns. Today's topic will be LLM for anomaly detection, and this is also his recent project. He presented this in the International NVIDIA GTC conference at Paris recently. So we shall begin with our session today. And now, Mr. Aditya, it's all yours. You can start up with your presentation. You can share the screen, and up to 3:30, it's all your time. Thank you.
Yes.
Thanks.
Only one small question. Should we just keep question answer during the presentation? I would prefer to do that because it could be interactive. Or what do you suggest?
Mr. Mehta, it totally depends on you and our audiences. They are very esteemed audiences. They're all faculty members, research scholars from various universities in India and institutions in India. If they try to, if they request you to stop somewhere and ask a question, they can. Or even if you want to interact with them, you can. You have got full liberty for that, as well as to our participants too. Or you can keep up some sort of Q&A session at the end of your talk, whatever you think deemed suitable. So thank you so very much. Thank you, everybody.
Screen is visible.
No, still not. Yes, it is visible.
Cool. So yeah, welcome everyone. So today's topic is the LLMs for the anomaly detection in the cloud. And
Please be there in this slide for a few seconds. We're gonna take a screenshot for this, sir.
Mhm.
Just a sec. Thank you. You must start.
Yeah, and also we can keep it interactive. So anytime you feel like asking questions or interrupt, just feel free to stop me in the between to raise the queries. And also at the end, we can have the Q&A session. So yeah, about today's topic, uh, this is
In
LLM.
a lighter vein, written by humans,
I
not
can't.
by AI.
Sorry,
No, no,
somebody
actually,
was
there is
speaking.
a thing written by humans, not by AI.
Yeah. That's what even I have observed, sir. Ganapati, sir,
Yes,
written
yes,
by
yes,
humans,
yes.
not by AI. That's a wonderful line that I've seen.
Thank you.
Yes,
Okay.
yes, it's a recent badge actually. So we can put our badge on the work which is created by humans. So yeah, you can even put for researcher or maybe for presentations and all this stuff. So this is a good badge ongoing these days. So let's begin. Uh, this is the agenda. At the high level, I will talk about, first of all, about the digital sovereignty and also about Open Telecom Cloud. This is just alternative. And then later on, we deep dive into the anomaly detection part with the languages model. And also, as you see in the background, this is Open Telecom Cloud. So this is what we work on as a cloud provider platform here. So this is the background of this. And in the end, we will have evaluation of the different LLMs and also some best practices which we learned. And later on, we see what is coming next in this world in the terms of AI, Gen AI, and also towards agentic AI. So this is high level agenda. And also I will have some demos. I will show some small little programs and we can follow along together with that. First of all, what is digital sovereignty? So as we know, tech space is really overpowered by the global hyperscalers like Microsoft, Amazon, Google. This is good, but there are some problems with this. That there is this Cloud Act in the US. What it means is this: if the US government wants, they can access the data anytime on any servers provided by these companies. So this is a problem for different countries these days, that if the US government decides, they can invade in the data at any time by their decision. And also there is lot of dependency on the US tech providers, and there is typical vendor lock-in. As we know that we are in an ecosystem of some companies, and then we have to keep renewing our licenses and all these things. So this digital sovereignty topic comes in picture. And for this, we are trying to build some systems which are independent of such hyperscalers. So this is the one, let's say, talking about the one possible solution. So yeah, we know AWS, Google Cloud, or Microsoft Azure. So similarly, I come from T Systems. So our company has this Open Telecom Cloud, which is another cloud platform. But main differentiation here is this: this is a European alternative. So basically, all the data as well as infrastructure as well as the storage of different digital system, that stays within Europe. That does not leave boundaries of European or even Germany's data centers. So this is one alternative for the digital sovereignty problem. And the reasons are simply like data protection, compliance, security. And also this is based on open source stuff. Basically, OpenStack is one method of creating the cloud resources. So it is based on open source system and reduces the vendor lock-in. And here you can click later on about these different websites. I have put this kind of stuff where you can just click later on from the presentation and see the whole portfolio. So for example, we know from Amazon, there is compute services like Elastic Cloud, or maybe from Google Cloud, let's say this cloud storage, or we all typically know of the buckets, this S3 buckets in the AWS. So this is just a small snippet of comparison of services which we have used in our project, which is LLM for anomaly detection. So I will deep dive later into the details, but this is just high level. Like for computing, we have this Elastic Cloud Server and function graph. For storage, this is the bucket. For application notification, basically like sending emails or SMS, we can use this service. And for the cloud data, we have this kind of services. Now let's jump to the problem of anomaly detection in the cloud. So in any cloud services, there are lots of operational data happening. Which server is having which kind of problems, maybe it memory related, CPU related, or maybe some other problems. So this is a really well-known field in itself, anomaly detection. And especially with the cloud, the cost can explode really quickly if we don't have a anomaly detector somewhere to find out the existing problems. So this kind of system helps to have early warning system, or maybe also for security threats, and it brings us some stability of the platform and our services in our operations. Manual monitoring is not a way when we have hundreds and thousands of servers and infrastructure running. And also we can have the service continuity and rapid response if we can detect anomalies in the cloud within good time. Let's jump. So traditionally, we used to do lots of typical statistical algorithm, manual data analysis, data science for the anomaly detection problem. But this time we tried something new. We thought, okay, can we just leverage LLMs for anomaly detection? Reason was this: LLMs got really good reasoning capabilities recently, and also these days they can play the role of reading JSON files or even CSV data, and they can perform basically a work of data analysis in a good way. So we thought to give it a try. The reason were specifically they have some good contextual understanding. They do not need any training as such. We just can use like plug and play the LLMs which are available, and also we can see different correlations as in about different metrics, how one metric is impacting the other metric. Similarly, we can have the automated grading as in, or if there is some anomaly, if there is some problem happening in the cloud, how can we identify it automatically using the LLMs if we give them data for this? And also these are dynamic, that at the runtime we can send the data to the this LLMs, and they can bring us the anomalies found in the data. This is a high level overview. What is our solution? So very basic. This is CloudEye. CloudEye is a service which collects the data of the cloud. It means which process is triggered, which resource is being consumed, and everything is recorded in this CloudEye service. And this is a storage thing, basically like a bucket. So in this data is stored. So we just get the operational data from the cloud of different resources, and we just keep storage in the buckets, and then we give this data to the language models for finding the anomalies. Later on, we have a dashboard where we can see overview of the different anomalies found, and as well as we can send notification to the emails or maybe to mobile phone via SMS service. So this is high level idea, like we just have a storage system, operational data, then LLMs to identify anomalies and then send the notification. First of all, before diving deep into the technical details, this is high level Gen AI tech stack these days, which is helpful because we are dealing with the LLMs. So at the foundation, we have typically the cloud infrastructure, as we talked, the typical global hyperscalers, and also OTC, which is alternative solution from Europe. Then on the top of this layer, we have the foundation models. So yeah, most likely we all know and use GPT these days, but there are other models also. For example, Gemini by Google, Meta Llama by Facebook, Gamma is also by Google, which is open source version. And on top of this, there are the frameworks. So frameworks are basically to use this kind of foundation models. Different frameworks, maybe most of you might have tried with PyTorch or TensorFlow in the machine learning projects. So these were traditional one, and the new ones are like Hugging Face or the LangChain models. On top of this is data orchestration process. So in this, these are some of the available tools. And then we can do fine tuning. Fine tuning is like, okay, ChatGPT is a general purpose model, but if I want to use it for my university, then I have to do it domain specific fine tuning. So I can use this kind of available platforms and tools to do domain specific knowledge enhancement in the LLM. Then there are typically embeddings and also synthetic data. So if we do not have a real data, how can we just use some synthetic data generated so that we can get good results? And there are also model supervision and safety at the top. So this is just for some fundamental things which we will deep dive into some of this stuff later on. Now, evaluation of LLMs. So at the top, you see different LLMs which are open source. Open source means code is available for public and anybody can try and change in the code and they can look what is actually giving the result, which LLM is bringing the result. And at the bottom are typically the closed source model as such by normal tech companies. So most of us are mostly using GPT by Chat GPT company. So this is a closed source model. Similarly, there is Cloud or maybe Grok, OpenAI. So these are basically on the top. You see the open source models, and at the bottom you see the closed source models. And also these blue cards are pre-trained models and the orange cards are instruction tuned. So these are pre-training ones and these are basically instruction one. So this is just recent evolution, and the reason I wanted to talk about this is normally when we think of LLM, we try to use only the closed source model, maybe buy a chat gpt subscription and start using it. But if you deep dive, maybe you do not need a closed source paid version and most of your requirements can be fulfilled by a normal open source model also. So we just have to look for the alternatives available for that. So this is the evolution about this. And now talking about open source LLMs. So what is the reason of using open source? First of all, things are transparent. We know which code is doing which kind of processes to bring some specific result. And also lots of security related features can be tested, and explainable AI is a big problem, which we know that why AI is giving the result it is giving. So typically in a closed source, the source code is with the company. We cannot know why it is happening, but in the open source, we can try to understand the code. We can just see how it is bringing. So this solves one problem of this explainability in the AI. Here there are two stuff. One is base model. So there is a base model. Then on top of that, there is a fine tuning. So for example, here you see at the bottom layer, these are different base models by different companies. Like this particular is by Llama. Llama is by Facebook simply. So it is a really well-known model in the open source area. Then GPT, the Chat GPT company, they also are forced to bring some open source models because they also want to be transparent. So this is also one GPT's open source model. Then there are other companies, and on the top we see fine tuning. So for example, Llama recently launched this model, and on top of this there are some fine tuning model which is specific to some domains. So this alpaca, or maybe let's say Vicuna GPT for all, this could be really specific to domain because these are fine tuned model. So this I wanted to highlight that open source LLMs is also really good alternative, and there are recently lots of development in this area. Now jumping to what are benefits of open source. So one thing is quantization. Basically, we can reduce the memory footprint that our model is consuming. As here we see for llama weights, a small comparison table. If we have number of billions of parameters are 7 billion, if we are using this much amount of RAM, like 28 GB, if we are using float 32 in the data processing. But if we just change this bits processing, how these bits are actually exchanged and how this data is internally processed, then we can actually half the memory requirement. And also, even if we go to store it as an integer of 8 bits rather than 16 or maybe 32, then we can even reduce further. So all this kind of memory reduction possibility comes up in the picture when we have this open source model. So this is called the process of quantization. This we can simply change the weights and the memory requirement for this. Then comes this efficient implementation for inference. So basically, we have the consumer hardware. Here we can use either the CPU version, and if we have the GPU, the graphical unit, then we can do advanced things also with the graphical unit. So here, overall idea is this: if we are okay with a bit of less precision, it's very negligible, but it is present. We cannot have 100% same accuracy as a closed source model. So this is a trade-off of memory requirement versus precision. So if we are okay with a little bit cost as a precision, we can change the memory requirement to store the LLMs in memory and use a open source model. Let's jump to local models now. So local models, what does it mean? By the name, it sounds like it's in my personal computer. So actually it means this only. Local LLMs is stored in my personal desktop computer, and typically these are LLMs which are used. And what benefits bring this? So it brings benefit of privacy, as you are not sharing data to any external company. Although model is trained by big companies, but still you have some control of privacy. Although privacy is an illusion if you are putting something on the internet, but still you have a little bit control about the cost. As I mentioned, you don't have to use a paid model because you have local LLM available on your system, and there are lots of free alternatives as we saw previously. Customization: you can deep dive into the code, make changes as when required, and also things are transparent in the local LLMs. Now the question comes, how do I access local LLM model? There are different frameworks for this. One framework which is Hugging Face, which we typically know for different AI platforms and frameworks and tools. Another platform is GPT for all, and also yet another is Olama. In my live demo, I will show you how Olama is working in my local system for different models, and we will do some small demo as well. So this is how we use local LLMs, which in the background use open source LLM, which are freely available. Now comes the question of our original problem of anomaly detection in the cloud. So just a brief recap that this is the operational data from the cloud, which we collect using function graph with some identity and access management. We store this data in this kind of buckets, and there is a elastic server here. It just means a kind of web server in which we have a GPU, a graphical unit. So we have one really powerful NVIDIA V100 GPU so that it can bring some advanced technical capability in the powerful processing. And then we have this anomaly detection dashboard with a web user interface, and also this message notification service as we mentioned. So if we want to use the Open Telecom Cloud, which is a European alternative, which is 100% in Germany, and data never leaves German data centers. So if we want to use local and this kind of open source LLMs, so we just need some server with a GPU. If we want powerful calculation, we need GPU. Otherwise, without GPU also, we can have a server just with the local LLMs installed. So when do we need this kind of thing? So when we need some really low latency or maybe some specific model architecture because it provides really good performance. And also if we want fine-grained control, basically we want to check everything and we want to make sure about the infrastructure and as well as the model. So we want some fine grained control over this entire ecosystem. Then we would like to use local LLM installed on a ECS server, on a web server simply. So this is one method of accessing local LLMs or open source LLM in OTC. There is another method. Let's say we want a managed service. We do not want to go through the hassle of installing, managing, maintaining the software because typically we have to upgrade the systems also for security patches. We have to make sure that latest release of the LLMs is maintained and all this. So if we want to let go of all this hassle of infrastructure management, there is one service provided by OTC which is called as LLM Hub. So in this, typically there are different APIs available, and we just can use it directly with the API. We don't have to worry about the infrastructure or how the things are maintained. So when we will need this kind of thing, when we want ease of integration, scalability, and also managed LLM. So this simply brings advantages, as in we are focusing on the LLM related processing with the API, and we are not worrying about the infrastructure management. So only main component which is different here is we are just using a API service here. So these are two methods in our project which we did. I will deep dive later on in these two methods in the live demo as well. Now let's jump about the implementation detail. So how we stored the data. So about the different data from our cloud services, we created this different kinds of buckets. So one bucket is storing all the output data from the LLM. Another bucket is storing input data for the LLM. And yet another bucket is just storing some functional graph dependencies, basically some uh, Python package libraries and all. So this is high level, the buckets required in this setup in our solution. Now let's jump about the data collection. So how we trigger the data collection process. So we created one function graph specifically that at midnight there is this particular API, Cloud Eye Service API. We collect the data and we store in the bucket as I showed previously. So we do it every day. And also there is another function graph which is doing a data collection. So simply this function graph is triggering the different API interconnectivity and all. So this process is making sure that at the midnight every day in the bucket there is the data coming from today's cloud resources for all different services, and later on we do processing with the LLMs as I mentioned. How does it look like? So there are some CSV files, obviously for the cloud data, and also there are some instances names. So in this text file, we store the different instances, which all resources are in my cloud ecosystem. And in this CSV file, we store the actual data. So that's how we create this kind of daily basis data for the cloud resources, and we store them in the bucket. Now just looking how this looks even deeper, how this CSV file looks like. So for example, this is storing the disk read bytes rate or maybe CPU utilization for one particular instance at one particular timestamp with the value. So this is how the data is stored, that different resources of the cloud. We all store this data with the timestamp for particular instance, for particular metric. There are almost different 13 to 14 metrics which are related to memory, CPU utilization, disk, or maybe network, and also other kind of cloud related processing. And on the right, as we see, this is just the instance name. So for example, this is a server which has this particular ID, and this is instance name for this server, which is stored in a text file, and in the CSV file the real data is stored. Now we deep dive into this flow diagram or overall architecture. So at the high level, there is a time trigger at midnight, which is basically using a function graph, which is triggering the code to get some identity and permissions related to call this Cloud Eye Service API. And then it stores one CSV and one text file on the bucket, as I mentioned. So here, really interesting thing is this all processing is happening in JSON. So we are not dealing it ourselves. This is function graph is automatically triggering. And later on, there is another function graph which basically creates this text to CSVs and also to JSON. So there is lot of data processing by LLMs, which is normally here. So what LLM does for us, which we typically will do ourselves. So first of all, this is storing 24 hours data. So LLM actually detects different chunks. So it divides one big data in different multiple files, and also it creates different kind of metrics related files. And later on, yeah, and later on there are some internal processing by LLM. So from the CSVs, it is trying to do anomaly detection, which is one abnormal data in the given CSV, and then it is converting into some JSON files. And later on, it is creating output that okay, this is all the anomalies found in the data in the given time period. And later on, all this data is stored and this is sent to the notification using the email service. So what here main difference is, as a typical traditional route, we used to do this kind of data processing manually, that we write our own code, we train our own model, we actually perform some kind of evaluation which model is doing this kind of processing and data analysis. And also we used to convert manually from CSV data to a JSON data, or maybe to text file for easier access and all. So this now change is, all this thing is done by LLM. So LLM is becoming the data analyst. It is checking CSV. It is understanding the different metrics, different data, and it is converting from one format to another and storing the results. So this all is happening through LLM. This is what high level difference comes up. About the implementation, this is just some script. So our code is entirely in Python and the Bash scripts. So at the high level, there are some pipeline scripts. So pipeline script means end-to-end process, how data is collected, which kind of permissions are there, which kind of resources. And then there are some pre-processing script. Before giving the data to LLM, obviously we have to give it in a good shape, as in LLMs can understand them better. So these data pre-processing scripts are just for making sure that LLMs are able to understand the data in a proper way. And this is simply anomaly detection scripts. So in this particular script, anomaly detector, Python script. Here we give it data for one single metric and we ask LLM, okay, can you identify anomaly? And obviously in the LLM prompt, we can give instruction, okay, you can use these algorithms and try to identify based on multiple typical statistical algorithm which anomalies do you detect. So this is detecting for single metric. Let's say I just give CPU utilization, so this anomaly detector Python script will bring me CPU utilization anomalies. And later on there is also this full table heat map. So in this, we are giving it all the different metrics. Let's say CPU utilization, memory consumption, maybe network incoming connection, network outgoing connection. So this is for full table heat map. Basically, we are giving entire data for all the metrics and asking LLM which anomalies do you detect in this. This configuration file are just for internal configuration of the systems, and this is storing the different resources names and instance IDs. So this how overall pipeline looks like about the different internal processing of this anomaly detector system for the cloud. Now let's jump to data pre-processing. So as we see here, this is a step of raw data ingestion. So in this step, we are basically collecting the data about the different metrics and identifying the relevant useful information and making sure that data is stored in a good format and structure for LLMs to understand. So this is how the code looks like at the high level. Now let's jump to pre-processing. So this is also how the internal file structure is organized. So for example, this is one particular cloud resource. This is how the data is divided into multiple chunks. The reason of chunk is this: we cannot give one GB file to a LLM and ask anomaly detection, because at this point LLM start hallucinating. So we have to make sure that we give data in smaller chunks so that output quality of the anomalies identified are reasonably good. So this is the reason of chunking, that we divide into chunks, and typically for a 24 hours data it is 8 to 9 chunks. So in a one day there are 8 to 9 chunks. So basically one chunk is having data of almost 3 hours, 3 hours or something like this. So these are different metrics like we are talking. This is disk read bytes rate, or maybe disk request rate, write rate, or here also network related stuff. So these are different metrics on which we are trying to identify the anomalies. Then we have the all the metrics stored in this CSV file, which is original values. What original values means? That all these metrics, individual metrics, they are combined in one single file, so that for 3 hours data, we can send this first chunk of original values to identify the metrics, different anomalies for all metrics. This is how it looks like. And also similarly here you see the different cloud instances. So this is just for one small snippet how it looks like in the background. Now coming to is sample chunk file. So this is about the CPU utilization of one particular instance of one particular date. So in this, as you can see, this is timestamp and the CPU utilization values. So what we will do traditionally is this: we have this data collected in the bucket. So we just give this data to our LLM and we ask the LLM, can you detect anomalies in the given data? And also, depending on the LLM of choice, the accuracy level changes, or maybe the processing performance level changes, the time of output coming up, it changes, and also the levels of hallucinations and also the reasoning power. So different LLMs have different reasoning capabilities. So we just feed this data to the LLMs with the timestamp for individual metric like here, and also later on with all the metrics together to create a heat map kind of thing. Now, coming to the implementation part of how these LLM requests are happening. So, one method I showed was about the Olama. Basically, we can use the local LLMs on the server. And second method is connecting it through the LLM hub, which is a provided managed service. So, this is how we give it a API call. So for example, we are using this model DeepSeek or maybe Llama. So we can just change the model name here, and we can send the request to this LLM hub server for this particular model. And then in the code, we can perform all this kind of anomaly detection, all this kind of internal data processing and all. So this is how you connect to the LLM hub for APIs, and there are different pricing model for this. For example, if the number of tokens are this many, we have to pay almost €3 for this. So this is just because it's a managed service. But if we want to avoid it, I already showed you the other way, which is using the local Olama model. I will show that in demo again about that. Coming to the LLM hub configuration. So this is obviously a Python code. So here we are just creating some configuration and sending the request to the LLM hub, because here we are not managing the model ourselves. So we just send the request to the hub to API call so that the anomalies can be detected on this given data. Now, coming back to one important point, how LLMs are detecting anomalies. So this is the most crucial thing. So it's all about prompt engineering, or these days so-called as context engineering. So we give this kind of good prompt to the LLM. As you can read, we describe it the data set which we are giving, and we call the LLM to understand the data, to also implement this kind of statistical algorithm. So for the anomaly detection, typically the SVMs, the support vector machines, or maybe even k-means clustering, or maybe isolation forest, all these are the statistical methods, really established ones for the anomaly detection problem. So we give LLM this prompt. Okay, you are the professional analyzer of the log data, and now you have to identify anomalies. And also later on, I describe the anomalies for multiple metrics and give me one single table or a single list, and also give me the reasoning about how you are bringing the results. So this is how the LLMs are performing anomaly detection or based on the given data. And now jumping to another version, which is about the grading. So in this, what do we mean by grading here? Grading is like, if we found some anomaly, is it really critical, or maybe it's a low priority or medium priority or high priority? So this kind of thing also we do not do ourselves, this manual data processing. We ask LLM to do this for us. So we just simply ask that can you identify this kind of list? Can you identify criticality or maybe the timestamp? And so this is the prompt which is given for this thing. Now jumping to next one. Yeah. When the CSV file is processed by the LLMs, they give one JSON file. So here as an example, we can see they give this JSON file and they give the timestamp and also the description why LLM is looking this number as an anomaly, what is the reason, and which kind of algorithm it is using to bring to that conclusion. So this is the JSON file created by LLM, which is further processed also by LLM itself. So we do lot of work outsourced to LLM in this scenario. Now, connecting the dots here. So how different metrics are interconnected. So as I told, original values data file has all the metrics. On top of this, we create a heat map file in which all the metrics are together, and we create a heat map as in is it anomaly or not anomaly, like number 0 or 1 binary data. And then we do description why the reason was to have some number as an anomaly, and the correlation also, if one metric is anomaly, why another metric is also anomaly or not, so vice versa. So this is how this looks like. Now, yeah, this I already mentioned. The different chunks are there. Data is in CSV. LLM processes and creates the specific JSON file, which contains the reasoning, which contains the criticality, which contains the output of the anomalies result. So this is how LLMs are doing this. And also this notification service. Notification service is just a simple email to our email inbox every day that on this particular instance or on this particular date, there is this kind of anomalies for this metric. So now this is in the user's control if they want to dig deeper and identify the problem and fix them. So this is how the entire anomaly detection dashboard using LLMs was created and designed. So till now, we jumped into the technical details, how internal processings are happening, how data is given from one step to another and all. Now we can go to live demo. But before this, if anybody has any questions, feel free to raise now.
Sir, hello, sir.
Yes, yes.
You have mentioned some when data is chunk, there is a bucket. So, what is that bucket? Basically?
Bucket is for storing the data.
Okay. So, it is all data is contained in that bucket.
Yes.
Okay.
Basically, there are three buckets. One is for input data. So this is for raw data. Another is for output data, which is the results by LLM. And third is just for internal processing of the Python scripts.
Okay. And sir, anomalies is basically the errors, or it can be anything. So, what is anomalies basically indicate?
Okay, yes. Anomaly means simply abnormal data. So, for example, this is CPU utilization. So, here you can think typically from traditional statistical approach that we calculate standard deviation or maybe variance, and we try to understand in this given 20 lines of data which number is really a outlier or a abnormal number. And then it is basically LLM is understanding, okay, it is CPU utilization. So it tries to give description also why it thinks this number as an anomaly, and based on which calculation, standard deviation, variance, or maybe isolation forest algorithm, or maybe even applying SVM algorithm.
Okay. So basically, this is only related to the particular data, not
Yes.
the. There is a one concept called as IDS, intrusion detection system, anomaly based IDS. So that is security part. Here is only data part.
Yes, exactly.
Okay.
It's like you can think of this as two step. First step is understanding and identifying the problems, and second step is, okay, there are security implications, so how do we fix them?
Okay. Thank you.
Yeah. And any other questions till now? Then we can take it now. Does not seem to be the case. Then too much of theory, too much of presentation. We can jump to the live demo. So I will show two, three stuff. One is Olama. Another is how we do local LLMs on the Elastic web server and also with the LLM hub. This is, I will show the anomalies, how it is being found by the different LLMs. And also I will show to do it with the workflow automation tool N8N. And this is the dashboard. So we have this deployed as a web service on this website. And this is the tech stack behind. So as we talked, Python is in the backend. For the front end user interface, we have Canvas.js, jQuery, and D3.js, typically the JavaScript libraries, so that it can handle the front end related stuff. And this Python Flask is just for web application, so that we can have all this as a single web application deployed on the some web server. So this is how it looks like. And so first of all, let me start with the demo of Olama. So for the Olama, this is the website olama.com. So as I told, this is for more local LLMs. So you can simply download it in your personal computer and start using the open source and local LLMs in your local computer. So as an example, I think my screen should be visible, right? So yeah, I am asking this LLM that can you bring anomalies in this data? And
So
this is the,
screen is not visible.
Screen is not visible.
okay, wait 1 second. Let me share again. Okay. Can you see now? Is it visible now?
No, sir. Now it's visible.
Do you see some white screen? Some
Yes.
Yes, sir. Yes, sir. Visible.
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 cool. Okay, yeah. So this is the Olama setup. So here I just show them some quick live demo. So 1 second, I just copy. Oh, sorry. I just copy this so that it will be easy for me to give this prompt. So let's say I go to a new chat and all these models are locally downloaded on my personal computer here. So this request is not going to some external API. Everything is in local. So let's say Quen model is by Alibaba Cloud. DeepSeek we already know, which was trying to have big competition with NVIDIA. So they also have these models. Then Google has these Gamma models, which are open source models. And also ChatGPT is in a force these days to bring some open source models. So they also have this 20 billion and 120 billion GPT open source model, which we can use for different use case. So I just clicked on new chat and this is how this Olama looks like. And all these models I just downloaded in my local system. For example, I don't have DeepSeek in my local system. And if I ask it some question, then it will start downloading the model. So just giving as an example how it works, you download it once and later on you can start using. Let's see, we take GPT as our all-time favorite 20 billion model and we give this data. So I'm just giving it a very basic prompt without giving more details which I was showing previously. I am just asking, can you bring anomalies in this data, which is CPU utilization. And this is the data, which is timestamp and the numbers. And I can ask it to do it by itself, or even I can give it algorithm name. Let's say I want to use the isolation forest or maybe SVM or all this. So let's say we just go as it is. So this 20 billion GPT will process it. It's everything in my local system, and it will bring the result hopefully in 1 2 seconds. So here we can see the thinking also, how it is reasoning about this. So it's calculating the numbers, it's understanding, okay, this is CPU utilization. So let me do typical standard deviation, variance, and all that stuff. Just one small thing is obviously there is this thinking. We can control this, as in there are some specific parameters. So if we don't want this much of thinking, we can actually reduce this and we can get the results faster. But this is just for demonstration purpose. You can see how it is bringing to the number. Um, because it is 20 billion parameter, it's lot of processing, but still normally within 10 seconds it brings the results of 3 hours data of CPU utilization. And now you see it is giving me big table also of the different results, and it is saying, okay, this is normal number, what is z score, is it an anomaly? Okay, this is an anomaly, as we see it highlighted with the bold also. So this is how it looks like for this, and now it gives results also, which algorithm, which calculation, the description of it, and also the Python code. So all this is happening by the GPT model, which is this 20 billion parameter one. But let's say I want quicker result. I don't want to wait this much time. So then we can use Gamma model, which is the model by Google, and we give the exact same question to this. Now I just switch the model from one to another, and you see within 1 second or even less than that, Google model Gamma was able to understand the data, and it brings me result that there are different deviation and numbers. So here it is giving me result this, that there are significant spike in this particular timestamp. So you can understand it, and also as I mentioned, we can control how much of the reasoning we want, how much time we want it to process for. So as we saw, 20 billion parameter took really long time, 1 billion took half second. So some like this, we can switch from one model to another uh, when we want to do lots of comparison, which model is giving good results and all. So this is the explanation or one demo of the uh, Olama, and all these are open source local LLMs, as I mentioned. So similarly, we can just give this to another model and ask the same question, and now it is using Quen. Quen is Alibaba Cloud's model, and it is 4 billion. So I hope that it will take a bit of some seconds. But this is how you can simply chat with the models, and this is local version of open source LLMs. So yeah, as you see, this also can identify this timestamp with CPU utilization as the anomaly, and now it is giving me reasoning. It's fine. I mean, we don't want to continue with this because we got the gist of the idea. So similarly, like this, this screen is also visible, right? Overall, can anybody see the screen? Visual Studio Code.
Yes, yes, it is.
Yes,
Yes,
yes.
sir.
So simply, as I was mentioning that these are different metrics, network, disk, or maybe CPU utilization, memory. So this is how the data is being sent to LLM, that this timestamp and these all different numbers. So let's say if I send this data, so obviously it will take more time to process. So typically for one complete day data, LLM can finish the task in 20 minutes to understand the problems in entire cloud for one day data. And it depends if we give it with more server, let's say with more GPU power, it can be even shorter duration. So this is what demo about the Olama models, and now I can show one demo of doing the same thing but using the Python script. So this terminal screen is also visible, or can you see the black screen here?
No, sir.
Ah, wait, I have to share again. Maybe it's is presenting only one thing at a time. One second, checking. Hopefully now it should be. Can you see the black screen, terminal screen?
Yes, sir.
Yes, sir.
Okay, cool, cool. Yeah. So yeah, let's say I just do the same thing here also. So I am giving this Python script one call to understand the CSV data and identify the anomalies. So now you see this is sending this request of all these numbers to the LLM, and it is processing. Simply it will do internal calculation for all these metrics, and it will store the results as is it an anomaly or not anomaly, simply using binary data. So like 0101 for different metrics. So this is typically row column structure, and as we see here, it identified, okay, there are these 2 3 low or maybe some medium anomalies, and it also stored results into the JSON file at this particular place. So this was using the local model, and I just give it a demo using the LLM hub, which is simply the another version of doing it using the API. So here I send it request to the LLM hub, and also similarly one CSV data with CPU utilization. As we see here, it is managed LLM, and also it's not local. So there are lots of API communications between multiple services. So it takes some couple of seconds more. So if you want really fast performance, then local is the best. This is what local server was, anomaly detector. This is a web server where we have Olama installed, and on the Olama, here you can see this is like we have downloaded all these models here, as you see Mistral, Gamma, or GPT, or all this on this server. So this was using the local Olama model. That's why the processing was super fast. And here it was using the hub. Basically, we don't manage LLM, we just use it as a service. So it was also able to bring the result that this timestamp, this found this anomaly, and how based on this particular algorithms which it processed, and it also gives description here. So we use these all results from this JSON file for our dashboard. So in the dashboard we show how one anomaly is found, on which reasoning, on which model. So yeah, these two things, and also one more thing I want to show is about doing it from the NA10. So one second. Can you see this? This screen is visible in the browser or not?
Sir, yes, sir. It's
Cool, cool. Okay, so this is NA10. NA10 is another tool which is this is the NA10. So this is more for workflow automation. So what do we mean by workflow automation? That we can automate most of the things which we use in our everyday life. So here, for example, there is an agent. Agent has some obviously some LLM like here Anthropic chat model. It also has some trigger which will trigger the process, and there are different outputs which will bring the answers. So we can use this N8N, which is all about workflow automation. So just want to give one small demo here also. So this is a kind of small chatbot. N8N is really easy to use. Again, you can download it in your local system and start playing around. So here are lots of components. Let's say which kind of things do you want. Are you interested in AI agents, or maybe you are interested in data transformation, converting from one format to another, maybe editing the HTML or CSV, or there are lots of possibility with N8N. This is more for automation of the process. So here as an example, I just created very simple process in which there is a chat box. So here I can chat to the model. In the between there is a AI agent. In this agent, we can actually even give it prompt also here. We can give all different settings and it will process based on that. Then this is connected to my local model. That's why it is Olama chat model. But you can, if you are interested, you can start, let's say, if you want another chat model, so you can use all the different kind of possible chat models. So let's say for the personal use cases, the Google Gemini chat model is really good because it gives almost 1 million as the context size, which is available free every day, which is not typically the case with other models. So for personal use cases, Google Gemini can be really good in the free version itself, and also that is open source version if you are using Gamma rather than Gemini. So there are lots of possibilities. Here, as I see, there is an agent and there is chat model. So as I can show here, I just connected it to my local system, local host in my personal laptop only on one particular port for the Olama to understand the different locally downloaded models. So that's all I need to connect this service here. And here I can see the different models which are downloaded. So let's say I'm using Gamma 2 as of now just as a demonstration purpose, and this respond is there. So this N8N is so easy. You can actually start building anything within 5 minutes, or even small. It does not need lot of time. So you just need to connect. Here are the component, and you bring this. So let's say I asked this question, who are you? Just as a demo. So it was the trigger to the process. Then there is this AI agent, which is simply using this LLM to bring the answer back. So as we can see, it is saying I am Gamma. Basically, it is giving the description what I asked. So as I mentioned, it is created by Google. Now let's say I ask the same question of, okay, I have this data and bring me anomalies on this CPU utilization. So I just sent this data. Or again, all this is happening locally. So this is another way of doing it. Previously, I described two different methods as well. So here you can see it was able to do it and understand that this outlier is at this particular timestamp for this value, and also there are explanation. Let's say it was considering z score, or maybe moving average, or maybe even time series analysis. So yeah, this is how it looks like in the N10. So this is all about the demos. So very briefly, just to recap, I showed demo using the Olama, using the local models, and another using the N10. And similarly, we saw the things happening on the server level using the Python script. I think this is it for this part, and now we can jump to another part. But are there any questions at this moment? Now we are just in the final stages, so if questions are there, you can raise.
Dear audience, if you're having any sort of queries, you can ask. Please feel free to ask. The attendance will be automatically marked today. The professional Google Meet backend attendance recorders. So need not worry about that. We'll have a small attendance at the end. You can ask some queries if you do have to Mr. Mehta. He is there from Germany right now. Please do ask him questions. We are having time lags. He has devoted his
Sir, in this data set, we have to put the values in the form of one zeros only, or normal data it will work on.
It
Means,
was working on normal data only. 10s was the output of the model.
okay. ठीक. So whatever existing models are present in that only we can work. In no other, we cannot propose or add something in that.
We can download new models if they are available in the open source space. And if we want to use some specific paid model, then we have to use through APIs because it's not locally available.
Okay, sir. Some new algorithm, etc., we cannot include into that.
Normally not, but typically in some couple of months cycle, the new models are also available.
Okay, sir. Thank you.
Yeah, we can go to the next part, which is just some, let's say, wrapping up the session. But there are also important consideration about the evaluation and also what's coming next. So in the evaluation part, there is this particular website called as LM Arena, which is a community website. So people like us who are using different LLMs for different tasks, let's say somebody is using for math as we did for anomaly detection, or maybe somebody is using for creativity, maybe instruction following, somebody is using for code, somebody is using for really long query, some philosophical conversation. So all these kind of different tasks can be done by LLM, and this particular website has different rankings, as in which model is best in which particular category and also overall. So as of today's screenshot, the Cloud Opus and Gemini are at the topmost overall ranking, but you can check later on this website from the presentation. This is just to see community driven work on which LLM to use for which task, and because all the people are submitting their evaluation, and it's a community driven project. Now comes to another part of how do I evaluate some LLM. So this is a typical question between low safety versus high safety. Maybe I am giving every much of my personal information to ChatGPT. That is a kind of low safety thing because there are no guardrails. Your data is shared to external party, and also lots of third party processing happens. But typically there is this two axis approach. It is versus low safety versus high safety. If you want your model to be really secure and your data to be secure, or maybe you want low safety with creative output. Similarly, Oracle is simply like the model knows everything or it pretends to know everything. And agentic is more towards model can also do some action on your behalf. So this is typically two-dimensional axis to evaluate the different models. As we see, the Grok model comes here, Cloudera, Anthropic comes here, Google models are here. They are not towards agentic approach more. OpenAI models are also not towards agentic. So they try to keep this more safe and less towards agentic. By agentic, we mean automatic actions by the LLM on your behalf. This is how we evaluate the models. In our particular project, this is what our evaluation was about the different model, how their performance was, and what was the result of our technical statistical comparison also. Overall, if I summarize this, Gamma 2 model by Google with 9 billion parameter, this was able to do really good quality and good accuracy results at a good speed. Otherwise, different models has different problems. Some model is maybe only hallucinating, some model needs more memory, or maybe some model are really super slow because they are really big size. Overall, in the LLM hub side, which was using the APIs, this model, Llama model, was really good fit. This is how we evaluated different models. And now coming one question. Okay, these LLMs were able to understand the problems in the given data, but are they actually statistically correct also? So we performed this comparison about this results of anomalies identified by the statistical approach. So here we performed typical traditional data analysis with isolation forest, and we try to compare it with the LLMs to understand the results difference. In this approach, we did consider temporal aspects, or maybe also we understood the different results and performed grid search for best combination of the results. Now coming to the result part, overall, if we see out of the results found out by statistical approach or maybe LLM approach, overall there was 91% similarity. And here you can see the similarity in the results for different individual metric about the outliers being found. As a conclusion, we understood by this overall project that LLMs are also able to do lots of data analysis tasks at a really good accuracy level, and we can rely the results as we see the similarity of the output by the two approaches. Now coming to some best practices about the prompt engineering. So one thing we have to make sure of doing some good data validation and also file validation before giving something to the LLMs. We have to make sure that things are in a really good structure or maybe semi-structure like CSV, XML, JSON. We have to make sure that there are no formatting issues in the output. Typically, when we use ChatGPT, it brings this character in the output. So we have to make sure that this kind of output are not being shown to the user. And also when we keep trying this APIs, that time we can have problem of failure of hitting rates because we are sending too many requests. So for this, we have to make sure to give some sleep and retry mechanism. Now, coming to the choice of LLMs, how do we choose one LLM for one reason or other? If you want local setup, Olama framework is really good. If you want, let's say, managed LLM, you don't want to worry about infra, you can use some provided service. If you want cost effectiveness, then open source models are much better. Then also we have to see the right fit of GPU, how much processing power we have from the graphical or memory side, and also how much is the big is the model. Then also we can consider the quantization and distillation. Basically, we can reduce the model size and we can do this as a trade-off for a small memory and still getting the good results. Coming to another best practice about the context. So as we know, garbage in, garbage out. So if data is shit, model is good, still the results will be bad. If data is really good, like a diamond, model is bad, then still the results will be bad. So what the companies are trying to push to make us using lots of context so that we can pay for lots of tokens for them. So companies are pushing, okay, this many tokens, this much is the price. But conclusion from our practice is this: bigger is not always better, because with lots of contextual things, there are long contextual failure. Maybe there is lots of hallucination which is happening in the context itself, or maybe context is overwhelming the model and it is creating some kind of distraction. There are unnecessary irrelevant details which is influencing the response, and also some parts of context are clashing with each other. So overall, context should not be really big, they should be really limited in size. On this similar topic, how do we manage to give good context to the model? So typically we talk about thinking outside the box, but sometimes when working with the LLMs, thinking inside the box helps, and we have to make sure that there are some constraints, and these constraints are the boundaries in which these LLMs and AI models can give the answer. So these are different techniques like context quarantine, or maybe pruning, summarization, offloading, and also we give selectively relevant information. So we have to make sure to give good context to get the good results. Now I just want to talk about quickly hype of the AI stuff. So this is the research by Gartner. So as of today, there are different technical hype cycle. One is something is really new, it's in innovation phase. Then there are peak of high expectations. Then there is disillusionment, people are disappointed. Then there is some knowledge coming up with slope of enlightenment, and there is a plateau at the end. As of today, AI agents is at the really high expectations, and generative AI is in terms of this disillusionment phase. So somehow generating AI has limitations, as we know, all the inaccuracies or maybe all hallucinations by the models. So this is just what is coming next. Similarly, in the Gen AI space, this is also by Gartner. So, in the Gen AI space, lots of new things are coming up with agentic AI, open source LLM, which I mentioned, model ops, also how models are operated and created in a automated workflows. So these are on the rise as of now. This is all high expectation. So we are still waiting how this really provides value, or this is really just a business hype. Now, just wrapping up, there, as I mentioned about the NA10, this is automation, workflow, and agentic AI. So overall, the world is moving towards agentic AI, where we are giving more power to the LLM. And by agentic, it means performing some action on behalf of the user. So this is just a small comparison between different. What is difference between automation or a workflow or a AI agent? And these are some tools. I demonstrated NA10 previously. Similarly, there is length flow also. Now, just call to action at the end. I really encourage to play around with Olama so that you can also download some model and use locally. Similarly, NA10, which I mentioned for workflow automation things, and all the details from our project, technical stuff, the code, everything is on this article which is published on this blog. You can check later on. And now wrapping up the session. So as I promised, this entire thing was written by human, not by AI. And for connecting more, here is the QR code. We can stay connected on LinkedIn. Thanks for the session. And if there are any questions, just bring up now.
So this open source LLMs, is there any links where we can get the names of all these? And
Yeah, normally on the Olama page you can check, and also you can do normal Google also, it will bring.
open source LLM means here we can script it based on our.
Sorry, say that question again.
We can change the parameters in open LLMs, right?
We can. Yeah, it's more of a technical code level changes, but we can tweak the parameters.
But code level changes we cannot do, just parameters we can change.
Parameters, yes, yes.
Not code level.
Code level also you can do by putting a GitHub request and putting the code level changes in a PR. And if they accept the PR, then it will be considered. It's a open source project, so community driven.
Okay. Thank you, sir.
Any more questions?
Sir, this generative AI, interpretable AI, and explainable AI. So, which one has the more scope to work on in research or
Which one you said? Gen AI and
interpretable AI and explainable AI?
scope in terms of what? Research or maybe
Research or means much where there is a more problem, so we can work on like that.
explainability is a really big problem because all this is as recently brought by Apple's research paper that all this output of LLMs is not intelligence, it's just a mathematical probability, but we don't know the explanation of exactly why some output is coming. Output is correct, okay, but this explainable AI is really big problem as of today.
Okay. Thank you, sir.
Any more questions?
Are there any more questions? Just a sec, sir. Let me have a screenshot of this.
Should I stop sharing?
Just a second, just a second. Any other queries you'd like to ask?
Hello. Hello.
Yes, audible.
Yes, sir. If I want to give one, research problem to undergraduate student based upon this particular topic, so what small problem I can give to that student so that they can learn
You
and
can
they will
actually,
implement some part of LLM.
yes, the best would be, to give problem of differences in the statistical versus the LLM results. This is a really important point because there are still limitations that all these results are not 100% accurate. There are still some limitations and hallucinations by LLM. So if we can go one level deeper to understand the reason of hallucination compared with the statistical approaches, this could be a really good research problem.
Okay, thank you, sir.
Yeah, welcome.
Any more questions or else uh, we'll finish this session here. I guess there are no more questions. Thank you, Mr. Aditya Mehta, for sparing your time, sitting way back at Germany. Thank you so very much, sir. And I hope that we'll request you again in coming future and most probably very soon again for some other gatherings, some other FDPs, conferences, technical talks, seminars, which we keep on organizing. Thank you so very much. Thank you. Thanks for inviting us. Thank you.
Thanks for inviting me, having me. Have a nice session for all of the other colleagues.
Thank you. Thank you. This whole stuff is sponsored by ICT Atal. Thank you. Thanks.
Thank you. Then have a nice day, everyone. Bye bye.
So now our next speaker is
Thank you, sir.
our next speaker is Mr. Pulkit Gupta. He's having almost 11 years of experience in data engineering. He is currently from UAE and In data engineering, he has worked for organizations like Wells and Fargo, JP Morgan, Cognizant, and many others. He is working on different projects related to banking, insurance, and healthcare banking services. So he's now with us. Mr. Gupta, are you there?
Hi, sir. Good afternoon to everyone. Good morning and good afternoon. I hope I'm visible.
Yeah,
I'm
probably.
audible as well. And thank you. Thanks, Partha sir, for giving such a wonderful opportunity to be part of the elite
AICTR.
faculty, AICT faculties. So thanks a lot, sir. About me, quick introduction. I hope everyone is all ready to start, right? I'm not going too quick or too slow. Let me know about the pace. All good, right, guys? So Uh, yeah, so basically about me, I'm Pulkit Gupta and I'm currently residing in Dubai, working for Emirates National Bank of Dubai, ENBD is the short form. There mainly I'm working for projects related to data engineering and some level to data sciences and how we are trying to club the AI models into data engineering and what level of optimizations and best works that we can try to do. Um, when we call AI, it goes, hand in hand with graphical user interfaces and the graphic cards being created, right? You might have heard of NVIDIA graphic cards, right? So all the different organizations at different levels, they are trying to bring in their own, capabilities. They are trying to develop their own capabilities to handle their overall data sets and overall execution capabilities and handling the AI models that are created. Okay, so this is something that we'll try to go ahead and try to talk about. So I'll quickly like to share my screen and then we can talk further. Before that, anyone having any queries, anything you want to ask? Okay,
Maybe after your talk, we will have some Q&A.
sure, sure. Um, okay, so let me know if screen is visible. So basically guys, we here we'll talk about AI banking solutions. What is the overall comprehensive utility and application of AI in our banking compliance and fraud detection technologies that that can help us to basically work for making our banking more stronger and efficient. So in the current day scenario, you might have heard of a lot of banking frauds that happens. There are various kind of traps and issues that come up, right? But at the back, the banks are continuously working day in and day out to go for resolving such issues, to go for handling such situations. Tell me, like, any one of you have been part of being done with any kind of fraud or near to your relatives? The answer from your end would be like someone or somewhere near to your relatives, or you might have come across some kind of frauds, right? um, but the resolution to that fraud is like the systems are continuously being monitored and altered and customized for a better response from the banking sector, so that such kind of frauds can be resolved up. Okay, so what we are going to discuss, what is our overall agenda, is our AI fundamentals in banking. Okay, what all core technologies we are using and how we are utilizing the various algorithms, okay, to fine tune our process. Then real time fraud detection, like in this we go for advanced level of monitoring and our compliance systems. Then we go for our implementation strategies. So that is what we as a data engineer and the data scientist try to achieve. Like we go by setting up our code scenarios involving the different type of cases, feeding it to the systems and trying to generate the overall result outputs. Okay, and then further, what are the kind of future trends, what can we expect out of AI, what are the outcomes that we can generate, what are the threats that we face through AI. Plus there are some common scenarios that go by. There can be job challenges, there are new jobs coming up. So there are both pros and cons that we face through AI, and that's what we will try to talk about mostly in terms of banking sector and how it impacts our overall executions, right? So if you see further, the 71% of financial institutions, they are currently trying to adopt to AI, and it is up from 66% in 2023. Basically they are adopting it, they are making a change and moving up very fast, right? Now when we talk about this technology, we have three basics that mostly constitute to our AI technology, that is machine learning, deep learning, and natural language processing, that is NLP, right? So in machine learning we have supervised learning and unsupervised learning. Now when I talk in terms of banking, right, so how you come across, like there are various models being created, uh, in which basically we try to overall handle the different anomalies, the different issues that come by, the different problem statements that are there in place. Okay, so how we go for that machine learning models, how we go for real time anomaly issue detections, complex pattern recognition, right? Then any kind of risk scoring is there, any kind of adaptive learning that we need to provide to system, and further like identity verification, right? So these all are coming under our uh, analysis for machine learning. Then deep learning, we have neural networks, we have multiple networks of which are visible and which are hidden, kind of complexities that we go for facing, the kind of issues and challenges, right? The behavioral analysis, the pattern identification, some complex patterns are being built over base patterns, right? So those kind of one after another, how we go for resolving such issues, that also comes from the data level of things. Like let's say your data is being masked, or it is being altered, or there is being alteration of the data records, as we go for saying. So how such issues can be handled through deep learning. And further, the natural language processing, basically the documentation and automating the overall compliance reports that are created, right? Now how the language processing can be enabled, how the chatbots can be handled, how we go for providing our overall data inputs. So that comes under natural language processing. Okay, so various bots go for reading and analyzing your instructions, go for understanding, so that comes under your natural language processing, right? Now when we talk about, right, the overall how is the market scenario, so you can see the adoption trends for AI. Okay, by 2023 to 40 billion by 27, and 32% compound annual growth rate, as criminals increasingly use the leverage AI. So there's been utility of AI on both sides. Okay, we are trying to do a very good monitoring about the various by utilizing the AI models, but at the same time the risk and threats of issues also keeps growing. So we have to be better monitored, better optimized, and better resolution providing, right? Okay, so how do we handle now what happened in the traditional systems? How do you go for handling the issues previously, and how we are handling it using the AI system? So earlier there were like rule based issues that were resolved, like static detection of various issues that you come across. Okay, there is the data being available, and manually we're trying to handle all those issues. What is the kind of data coming, what is the fraud analysis that we can do, is there any abnormal values that you can analyze. But lot of time, efforts and duration went by before trying to track that particular issue. Okay, so there can be, suppose there is a huge payment being done, but we are not analyzing, we are just passing it by. Okay, we are not able to track it because at data level, at a normal human eye level, you cannot go for analyzing each and everything right away. If some patterns keeps repeating after long interval of time, again we cannot go for analyzing such issues, right? Only when such sudden issues happen one after another, after third, and it is being reported, that comes to. Now when I say such issues cannot be handled or reported very quickly, it's not the like anyone lacks efficiency, but the problem is to analyze where the issue is happening. Okay, and how frequently it is being optimized, your systems are being executed and done. Suppose the business, okay, how it comes is business has to bring various level of issues and incidents, suppose P1 incident, P2 incidents and P3 incidents that keeps happening. So there are specific teams that are there to handle a particular scenario. Suppose a user is aware and reports a fraud or reports mismatch of the suppose in the dirhams there is some mismatch value. Instead of 25,000 AED, his suppose salary is showing as 5,000 AEDs, right? So what is a mismatch? 20,000 AED of mismatch, which is a huge sum, right? And then such issues needs to be analyzed, detected, plus there has to be a governance as well of how and where the money went, right? Whether it's a data issue or it is a actual fraud and amount is being pulled out of the account. So all these issues needs to be handled with much optimized manner. That's where our AI systems can help us, right? In the traditional systems there were high false positive rates, causing the customer friction, customer issues. Like suppose as a banker, right, I stopped someone's transaction because it was a high value transaction. Now suppose that transaction was a right one. Okay, so this is again, like if we over optimize our systems, then there can be an issue that even the legal or the correct transactions are being held, which is going to cost you the customer, right? So such kind of issues also happen, like where okay, the transaction amount is not happening frequently, but it happened and we stopped it, right? So again, that is a challenge, right? Next, batch processing delay. Now what is batch processing? Everyone is aware about batch processing and real time data availability, guys?
Yes, sir.
Yeah. Okay, so you are aware, right? Batch processing. Suppose there are set of files or data that is coming up, okay, that is coming from the source, and they are arranged in some batches. Or suppose there is a downtime in the system, so batch of data is being stalled, or the real time data is not being available. So the data cannot be updated. One such scenario that I remember from my past, I can tell you, like there was a Amazon share split. Okay, it was done by various organizations handling it, and at the back end there was JP Morgan and BlackRock also being a part of it. So in such scenarios, because they are the people handling the lot of money from these Amazon and Walmart kind of organizations, so the share is split. Now on the sharing platform, the data has to be available on T-1 basis, but it was available on T-2 basis. And after the split, there was a huge panic, even though the notifications were sent out to the various customers. Now imagine you have 100 shares of Amazon and each share is split into 5. So ideally the person should have 500 shares, and calculating the amount of value to which it will impact, you can imagine, right? So even though the notifications are sent, but the share base is so high, the customer number of customers are so high, there can be chances of panic situations that might happen after share split. So how do we take care of it, right? So in batch processing, there are chances of delay that happens because the data might not be coming or might be stalled, correct? In the AI systems, we are trying to address and resolve such situations, right? We are doing machine learning adaptive algorithms for continuous improvement. Like any rule base that we are setting, instead we are taking the different calculative and mathematical algorithms to handle the overall situation. We are putting in the logics to handle. So algorithm, reading the algorithm and structures is something of utmost importance in today's time, because these algorithms as capable and as better they are going to train and test and train your overall data models that are being utilized. Then next is like high false positive rates that I mentioned. So basically you have the behavioral reading, okay, like what are the profiling, behavior profiling, how a customer is dealing. So if I stop a customer who do not have frequent high value transactions, is a one fine good thing, and as a good service it would be counted. But suppose I stop transaction of a customer who is frequently doing the transaction, okay, even though high value transaction, they are frequently trying to do the transaction, suppose in a day 3 transactions of high value. So it needs to be alarmed whether it's a proper transaction or there is chance of some falsehood that can happen, or someone is trying to take money out of some others accounts. So that way we have to understand the behavior patterns. So earlier, if I try to tell it in the layman terms, right, suppose there is a engineer, architectural engineer, he will initially place the overall value in 2D. The drawings were developed in 2 dimensions, right? Now there is 3 dimensional drawing that have come up that kind of picturizes and shows you the overall blueprint of how things are being handled, correct? So 2D, you cannot, like 2 dimensional ways, you cannot give all the nuances or all the issues or problems or height and weight and everything. You cannot just mention it, or even if it is mentioned, it would be very, very technical. But to make it available and easy understanding for the larger customer base, 3D models would be much better. Agreed, right? So that way, the behavioral profiling of candidate, okay, not the transaction limit to be set up to the different accounts and how they needs to be handled, right? And finally the batch processing of the data, instead of it we have various tools and technologies, like Apache being a lead, who has taken the lead, like with various tools and technologies like Apache Kafka, Apache Flink, right? So real time analysis of data enabling the immediate fraud prevention. So suppose a fraud happened, this is a real example that happened. One of my friend, he got a card. Now India's payment gateways and credit cards and technology, I would say and feel, is much much way ahead. Like the boom that Paytm has bring, Bharat Pay, Paytm, and so many, they are much more secured and in a much advanced state when it comes to fraud detections and issues that are being handled in UAE. A credit card being borrowed and just being activated in the midnight hours, a transaction to a level of 8,000 AED happened, right? Now the person has to go back, report a complaint, talk to the bank customer care, and still after they take a duration of 90 days to resolve the issue, and there is no much of a issue resolution. Only 20% of amount is being refunded, and various reasons are being given for that. So that kind of issues create huge panic among among people, among the customers, when your hard earned money is being mishandled, to any kind of fraud. So this is, we are trying to bring in more AI systems, we are trying to bring in more optimizations, and we are trying to implement more solutions. Okay, so this same thing that we talked about, like anomaly detection, like through advanced algorithms, we go for neural networks, we go for unsupervised learning detection, finding unknown frauds, and then pattern recognition algorithms. So there are various algorithms that we can implement and we can work through, and we can try to find the new anomalies or new issues that come up. Then behavioral analysis, again, they go for trying to track all your details. Earlier, if you remember, we used to go to bank branches and we used to open the accounts and finding lot many, you need to give references to open your account. Now it is all done on a touch of button. You have to be present in front of your screen with proper visibility and your biometrics being captured, right? So all of these enhancements goes for better recognition, better identification of the issues, and brings down the number of frauds that happen. Okay, then the compliance. Now compliance is something very important. Okay, so what comes under banking compliance, what all things, compliance basically means the rules and regulations, right? So what all compliance you guys think bank are making, or it should make in order for running the banks smoothly? Any inputs, guys? What level of compliances or what compliance you are being a part of? Any idea? No? Right. Okay. So you might all be aware of anti money laundering. You might have heard of anti money laundering. You might have heard of KYC. Right. Every one of us go for having a KYC. Know your customer, then the regulatory intelligence and reporting. So what happens in the KYC? We go for providing our details, our names, our references, right? Any any beneficiaries to be added, so that such is also an issue. Like earlier the bank accounts were opened but there were no proper beneficiaries added, and a lot of amount remains in the bank, even though it is in thousands and hundreds. Such amount keep accumulating in the banks with no one to own them. Okay, so all those are important as a part of compliance. Then regulatory intelligence and reporting, basically what happens in current scenarios, how the times are changing, how the new threats can be available, or how better facilities we can provide. Earlier we used to have all the clerical works done, entries being done, that suppose all of that is stored in the diary or the books, right? That all can be open, and the information or the privacy can be shared very fast and very easily, right? Now all those issues are much more compliant. There is more privacy that we are trying to provide. um, Anyone cannot have access to your accounts or what transactions you are doing, but definitely those are at the same time open to the government of India. Okay, and to the government of the world. They can have the access to each of your transactions. If there is any kind of frauds happening, if there is any kind of illegal money traveling, all those are the kind of situations that comes to banking at each and every point in time. And there can be huge issues if such regulatories are not in place, if the transactions are not monitored, and if they are like just moving like anything, then there can be huge mess that can happen and no one can imagine of, right? So because of all of these issues coming up, we are more and more complying to each of these technologies using AI as well. Okay, so another thing, It can analyze massive amounts of transactions to identify suspicious patterns instantly. And the various learning, right, the supervised learning and the unsupervised learning models. So if you see the algorithms that I was talking about, right, so there is random forest, svm, and neural networks, and how these algorithms are applied. We go for reading the data from the source, processing it, and then trying to transform and load it. Once the data is loaded, then we go for applying the algorithms on the data that is available. Okay, and then we go for training and testing the model. Let me try to show you. Okay, not as a slide, but how the data process happens. Mm, let me- mm, is my screen visible? Can you guys confirm? A notepad is what I'm trying to show you here.
Yes, sir. Yes, sir.
Okay, great. Thanks for confirmation, guys. So now what happens, right? Let me try to just simplify it on how the overall processes works, right? So even though AI is an enabler, we also need to have the fine tuning of the overall process. The important crux is still the data that is available. Okay, how the data is available, what we can analyze through that data, what we can identify and read through the data that is present with our you know in general understanding. So first of all, there is different kind of data that is present. You can have the json file, the xml files, flat files, right? Then there is a structured, semi-structured, and unstructured set of data that is present. Okay, then there is the databases. You might have heard of oracle databases, then aws, and various cloud platforms also holding the data storage, right? Now earlier the system that were there were on premise system. Now each of the systems are tried to be deviated and settled up over to the cloud. It's a kind of plug and play service that we kind of set up. Based on the data sizes, we can structure, organize, and reuse the cloud platforms. So suppose there are n number of data sources that are available for banking. You can think of there are various data source systems of customer table. Suppose there is, I give you an example, there is customer table, then there is employee tables, then there is a detail about customer accounts. One customer having multiple accounts. Okay, one customer having accounts in multiple banks. Suppose if we talk in terms of rbi, so they need to, or income tax, right? They need to have a cumulative identification of how many accounts a person is having, what kind of transactions are happening, right? And whether they are a valid transaction or not a valid transaction. So basically aggregating all the data in terms of a particular customer. When we talk about the banking compliance, and we call it C360. Okay, C360 means customer 360 view of what are your requirements, whether you need a loan, whether what is the transaction you are doing, what business you are into, right? What is the kind of earning you are having, whether you fall in a upper class, middle class, or a lower class. I don't want to disintegrate based on like salaries, but that is the category being mentioned about transactions, and to have a better understanding that frauds are avoided, right? So all these data can be accumulated. Then important part is file reading. Now why file reading is important? Any inputs from anyone? Why reading the data is important, and what kind of data is made available is important, guys? Anyone, sir?
Sir, for reading, hello.
Yeah, sir, please go ahead. Yeah.
Means
Uh, you are not audible.
sir, what's your question? Can you have repeat, sir?
Yeah. So, if my screen is visible to you, my question is why data reading and data cleansing is important. Why having to read the data from different kind of data files are available, right? So, why having to read the data and data cleansing is an important part to progress, and being it AI or being it data processing or being it showing records to customer. What is the importance of this? Generally, we call it ETL, data extraction, transformation, and load. So, what is the importance and utility of it, and how valid it is? Any idea?
Basically, valuable information we can get it through that. If the data is proper, it is if it is cleaned and integrated from multiple sources, so consistent information can be there like that.
Correct. Very nice point that you mentioned. Information, right? So, only
Yes, sir.
data
Thank you.
is of no use. Yeah. Thanks. Thank you. Anyone else wants to give any inputs? Okay. So, sorry, coming back. So what I basically want to say is any kind of issues that you can think of related to AI, right? We call it outliers, we call it hallucinations, we call it wrong data, and then we try to keep working on how to remove it, right? So it is a backtrack approach, a reverse engineering approach. So ultimately, whatever you do, wherever you go, whatever technologies or algorithms you apply, the basic to everything is data. And the energy that data gives you basically is you convert your data to information. Okay, one term being utilized, information. So when you extract the useful inputs out of your data, there can be n number of dimensions of the data that are available. Suppose there are time dimensions, there is degenerated dimensions, then there is unstructured data, there is less utility data, specific to your case. There is huge amount of data that is available throughout. Every second, millisecond, we are producing the data. Okay, being it structured, unstructured, doesn't matter, but we are producing the data. Even with a click of my mouse, I'm producing some level of data. Even if I'm typing something, we are doing something. Okay. uh, uh, the main business is being governed here. If you talk about organizations like Walmart, Amazon, or Flipkart, or any big organization, they are taking your data. Okay, they give you offers, nothing is for free. They are trying to buy your patterns, and these patterns, right? Suppose you are ordering um, a balloon, okay, or a set of balloon packets of balloon. You are giving an indirect information of having a kid in your home. Or suppose you are buying something for a holiday, right? Someone going to Goa and purchasing the products online, right? So they get to understand that you are now in a traveling mode. Now imagine hundreds and millions of people traveling each month, okay, especially in the festive times or in the off season, right? Or during the Diwali season, right? Whatever, they get to understand and analyze what is the requirement. And imagine millions of people giving their information. Now that information is used to play with the prices of each and every product that you will go for ordering. Okay, what to make shortages of, what to make more available, how to store, what patterns of what patterns of product to be stored. Okay, or even it is even drilled down to you are belonging to which country, which city, which district, and which pin code. So that level of detail is being extracted, and all of these being fed into the models that we are talking about, the AI model in the supervised learning platform or the unsupervised learning platforms. Or we are utilizing various algorithms. They bring out the best of what can be the best of what business results can be driven out of it. So that is the power of data and the data processing. if there is any kind of faulty data, huge miscalculations and misalignments happens. Okay, that's why when I talk about ETL as a part of it, um, we are going for data extraction, transformation, and loading. So when I talk about extraction, we just discuss. Next is we talked about the data being available in batches or in real time data that is available for us. Okay, what is the what pattern of data that is available to us, whether it is in batches, that means there is a batch of record, it can be like per day of data being processed. Now in real time data, we are talking about every seconds and milliseconds of data that is being fed. Suppose you give an input, hi, how are you, and I give you a response, I'm good. So that is a quick connection of what we are trying to develop using the various big data technologies. When I talk about like Kafka, Flink, and various other tools that are available, and open source technologies that are available, over and above that, we go for applying our various AI models. Like there is Chat GPT, then there's right, GPT, Gemini, then Llama, Olama models that are there, which are open source, right? So all these are being applied. The processing of the data is being done, and then we further go for transforming the overall record. Suppose I want to have the category of people whose earning range is about 3 lakh per month. Okay, or also I want to have people whose earning range is below 20,000 per month, and we want to, like, suppose government want to put some policies related to that, right, on how and what patterns they are earning and not earning, or how the overall family structure is supported, how that overall tree is being created. So basically we go for creating the decision tree metrics out of whatever information is being provided. Then further we go for ranking, ordering, sorting of the data. So those are called as the transformation logics, or the filters that we go for applying to the overall data. Okay, and then further we go for like how and when the data is available, whether it is available in the form of images, jpgs, structure, unstructured, organized, unorganized. If unorganized, then how to filter it. So that is uh, how the processing of the data happens. Before moving further, guys, I hope what I am discussing is useful, because I am bit off the topic, trying to explain things on the data level side as well, along with the AI and how it is implemented. Partha sir and everyone, is it fine, or we continue to the main slides? I'm just trying to give the practical implementations. Am I audible? Okay. Okay. So I think this is information that I wanted to provide of how everything is working at a backend and how the data is being handled. Moving further, one second. Okay, so this is what, so once that overall data set is available for us, right, then we go for applying these neural networks and basic training algorithms. So there are various supervised training algorithms and unsupervised training algorithms that are present. Okay, but we then in unsupervised we have the DB scan. Okay, it goes for identifying the outliers in the transaction data that is available without having any prior knowledge. So what happens in the supervised learning is, when you are telling someone to follow a set of rules, making them to understand, or a basic knowledge input of what you're trying to provide to a person. Okay, suppose if I'm showing you a direction, okay, move left, then right, then center, and go ahead. So that is basic, and I am also monitoring you. So that's a supervised learning. Whereas unsupervised learning would be I told you, okay, how to follow the routes, how to check the locations, what are the directions being provided, and you go up on your own and try to find out the places. There can be wrong direction, right directions, that we can call it as outliers. You can go to extreme wrong paths and then follow and come back, right? So basically in the unsupervised learning you have much more inputs of your own, and also it implements you the basic and high level decision making powers as well. Okay, so that is being followed. The overall data pre-processing, model development, and the performance monitoring, basically what happens overall in the execution. So this we, I think, discussed in a bit deeper detail of how the data processing happens, right? So there the feature engineering, right, understanding the patterns, transactions, behaviors, and how the overall uh, transactions are being taken care of. Further we go for data cleaning. So this part also we discussed. There can be missing values, there can be outliers, there can be some unwanted. Suppose I'm dealing in dollars and there's a mention of rupees, right? So these are kind of outliers that can come in the data, right? If you're talking about dollar, then INR cannot is something that has to be dealt separately. Okay, or AED dirhams has to be handled separately from the um, dollar value, right? So that way we go for huge data pre-processing, so that the model have the fine-tuned set of data that is available. If the data is having the issue, then believe me, any algorithm or model cannot help or support until and unless you have the best possible data sets that are present, right? Then we go for the further model development, where we go for selecting what algorithms to process, what algorithms to provide. Okay, and then we go for execution based on the training process. Testing and training for the models is what we do. Then we go for the model validation, and finally deployment to the pipelines. When I say deployment to pipelines, so this is the CI/CD process continuously being followed. Like we have the development and like data processing, data pre-processing being done. It is done in first environment, then second environment, and third environment mostly. Like we call it UAT, then QA testing, and then finally deploying it for the pre-prod and the prod environments. Okay, so 3 level of basic testings, and each level has to be governed by peers, checked before deploying, that this is not going to break something which might already be running, a best of process that is getting executed, and then finally deploying it to the pipeline. Now at this level also there is the AI efficiencies being involved. Okay, and how this model development happens, let me try to provide that as well as a quick review. Mm, okay, so if you see this side, right, I try to showcase a particular programming logic of how your model development will happen, right? So there's these different libraries that are already being available. There's pandas library, sklearn, right? And we go for importing the various libraries, isolation forest, train test split of the data, right? Model selections, right? So what we do is, once the data is available, we convert it into a format of a data frame. Okay, this data frame has all the data inputs that we provide in the start. Sorry, um, the data sizes are huge. We have the large data sets being read, and what particular random data picks we want to do, accordingly we go for data importing. Then we create a data frame out of it. Further we go for engineering of the data, of whether we want to drill it down to the transactional times of hour, minute, week, or month, right? And then further what is happening is, okay, this particular transaction happening at a particular merchant level, so what is the location of that particular merchant, and is the transaction happening, and the location of the customer. Suppose I am sitting in India and the transaction is happening in Dubai, right? So that is a huge issue that can happen, right? So what is the location, accordingly the transaction has to be validated or not to be validated, right? So for that particular analysis and training the model of what kind of outputs are being generated, right? And this is isolation for us, and through that it is um, assuming and analyzing the percent of anomalies or the success or failure rate, basically we can say, and then prediction and risk scoring, whether the particular transaction happened is a risky transaction or it's not a risky transaction, right? There are various gaming platforms you might have heard of currently happened for Dream 11, right? In India there are regulatories being set up where the particular transactions has to be monitored, that each of the customer is not having huge losses and they are not going in depth and ultimately creating some bad news or some sorrow situations for any kind of family or individuals that are there or being involved, right? So anything that involves risk, those risk has to be mitigated, and the proper solutions and structural decisions has to be put in place in order to basically organize or perform the best of operations. Next, so this is what I mentioned, and then the performance monitoring. So as and when you keep on training and testing your models, you keep organizing your models in a much oriented and better ways, you will keep getting better results. Okay, and then there is a feedback loop where you keep incorporating any kind of new patterns, issues or frauds that happen, and you keep tracking and getting those particular data set involved and make it a part of your existing models, right? So what all things we go for doing as a part of it, we go for real time monitoring of the data. Okay, we go for graphical analysis of the data. When I say real time monitoring, like suppose we are finding the risk score in the previous program, so that particular risk score is above the threshold, then basically trigger an alert situation to the customer and to the bank that these transactions are fraudulent transaction or these transactions are risky transactions, depending on what kind of model set you have prepared, right? Even in the if we are transacting in mutual funds and shares, especially in the mutual funds and SIPs, there are high risk, low risk, middle level risk transactions that are happening. The different returns and the risk levels are associated there, right? So they are also following some level of algorithms and training their overall models to make decision and offering it to the customers for their choice making, right? In the graphical analysis, suppose a graph is going above and suddenly it falls down, then what is the reason for that failure, or why the graph has started going in the negative direction or it is going in the opposite direction, right? So such kind of graphical analysis also help to understand the overall identity and execution that is there. um any questions till this point, guys? Any, are we good? Guys, am I audible? Okay. uh okay, thanks Kevna. So moving further, these all for compliance automation, the monitoring, the execution, and natural language processing and automated KYC is what we follow. For real-time tech solutions, we keep on creating the real time regulatory change monitoring and impact assessment, because we have to explain if something has happened, good or bad. Bank as an institution has to follow a set of process. They have to report any kind of issues that happened, and it can be escalated to multiple levels. Okay, and those escalations needs to be handled. This is the overall roadmap that we discussed about, of how the overall processing happens, the data collection, right, then model training, then integration, and then further testing the models, training the models, and then continuously monitoring it for the good, better, and best situations, right? And we go for implementing the overall success rates. Okay, so around $4 billion of fraud prevention happened in the banking industry. Okay, and 90% of the false positive being resolved, right? Anti-money laundering transaction monitoring happens very frequently, what all transactions are happening, correct? And then what are the various challenges that we face, and what are the different solutions that we can propose regarding to these AI challenge, the challenges in today's time and the solutions that we can provide. So first and foremost, again, data quality and consistency issues across multiple systems. So we, any kind of data platform is available, any kind of data source is available, being it image, being it PDF, being it JSON or Excel files or anything, right? Structured, unstructured, or semi-structured, any format of data is present. You need to analyze, understand, and put it into the regulations of what exactly is required, right? So through AI solution, we try to create the pipeline. One thing that I skipped in previous slide, like how we are putting AI solution to each of the processes, even as a developer, as a architect, how these AI solutions are optimizing the process basically. So when you have the different data sources available, these AI solution, we basically create an agentic AI solutions, where the agent is going to recognize the data sizes, okay, the number of data sources, n number of data sources that can be present. So it is not possible that every day you have huge volume of data. So accordingly, the resource optimization and utilization in the DevOps process, right? Like how many resources or threads are required for me to process the data as per today's data strength. On the festive occasion, the data sizes would be larger. On normal days, the data size would be lesser. So to optimize the number of resources, to put in the number of pipelines or chains to execute, to provide the number of resource of how much to execute, and what are the different data sources, so all that can be controlled and monitored, right? All the mundane jobs can be removed, all the repetitive tasks can be handled by automating these patterns that we are following in our day-to-day life and in the engineering platforms, right? Then regulatory compliance complexity and changing requirements. So another challenge is our systems in the today's time are not efficient enough that they implement rules and regulations on all the changing transaction models that are happening. There's Bitcoin, there's share market, then there's unstructured transactions happening in the villages and the cities and everywhere. Then there is a regulatory payments that are happening, and the proper detail of transactions that are happening. So all those complexities, and if there is any issues, then to explain that, right, we can go for applying various algorithm, but there can be algorithm level um, um, base check as well, like okay, to what level these algorithms are working properly, whether the return from a particular model applied is 90% or 50% or 70% or 99%, what is the accuracy rate, and if there is any better way to optimize the processes, there is any way to reduce the time, right? So all of that regulatory compliance and normal compliance issues needs to be addressed, and modern interpretability and explainable AI requirements. So what is the requirement, what are the solutions we are implementing through AI, and whether they are being governed and monitored, and we have a proper decision making transparency. Like with agentic AI models being created, those agents will make a decision on behalf of you. Okay, lot many trading platforms are now working on these agentic models. So even though the decision is being made, there would be humans that are responsible to agreeing to apply those models, right? So the basic responsibility falls upon on who would be made responsible, and whether these transactions and everything is happening properly. Because on one side we are trying to optimize everything through AI, but on the other side there are challenges that are generating through AI. So it has to be explainable of what is the decision being taken by a particular model, and whether that best suits the interest of people and the humanity, right? So this is the performance metrics, the model
Sir,
evaluation and
sir,
monitoring.
hello,
Yeah.
sir.
Yes, yes, yes.
Can you just show that implementation roadmap screen just previous to that?
Okay, just allow me a second. Implementation. Yes, roadmap. Yeah. Is it visible?
So,
Yeah.
yes, sir. Sir, in bank, data integration is needed.
Sorry.
Data integration is required, sir, in
Always.
banks.
Yes, yes, yes. So I cannot keep on suppose you are having a bank account, right? If I show
Uh,
you a transaction of 5 days back in your account, and after that suppose you got a huge lump sum amount, so wouldn't you be in panic if I go for integrate, like if I let the data as is, I do not integrate and bring the latest set of records for you, right? So in banking there has to be continuous integration, because there is a value chain involved, there is money involved, and the financial transactions being involved. So the data has to be continuously integrated, especially in the banking or in any field for that matter. Make sense, sir?
sir, means, sir, in bank, you are using some tools for integration or
Yeah, so when I talk about the data integrating tools, so there are like freewares also, like open source also being available now, right? Open source and then there are tools like Informatica, Ab Initio, right? Then there are various tools that can be utilized, and now things are becoming more open to big data handling and open source. So now we are utilizing Python, PySpark, right, Java, and various programming languages to go
okay.
for achieving the same set of result that we used to achieve through the tools. Yeah.
Open source tools are there, sir? Any tools for data integration?
Like you can use this Python and PySpark if you are
Okay.
it's not tool, it's a programming language, but now they can very well try and perform the what results we used to get through the various tools. Now you can easily get for data processing, you can get through them. I hope
Okay.
you're talking about the data processing tools, right?
Data integration tools.
Data processing and integration will go hand in hand, so you have
Okay.
to work on these tools simultaneously.
Okay. And sir, we don't have any data to work on for banking domain, like data set where from
There's huge data sets available. You can go to the Kaggle. Okay, you can go for those competitions where Kaggle you can register. You can register for banking related problem issues or any financial issues, and you can get huge amounts of free data sets being available. So in today's time, like initially to start working, you can work on these platforms, and once suppose your candidates or students are in the industry, because sharing the real time data and sharing the, like even we as a developers have the data masking. We do not deal with we cannot have access to individual customer data as per the regulatory measures. So suppose if I have your account and your bank balance or something, so that's not a good practice or a best practice, so that is always being avoided. so that because of the criticality of the data, it is always being masked and then shared.
Thank you, sir. Thank you.
Yeah, makes sense, right? Okay, any other questions, sir? Anyone?
Oh, thank you, sir.
Okay, okay, thanks Vijay. um, okay, so moving forward. Oh, sorry. uh, yeah, moving forward, we talked about this challenges, solutions. Okay, so this is the performance metrics that we discussed, right? It was somewhere around 94% and it is continuously increasing year by year from 24 to 25. The overall performance tracking, like how the fraud detection systems are maintaining the optimal effectiveness. If there is any kind of imbalance to that, then it calls for, issue resolution and handling those issues at the best. Now these points that we talked about, like the deep learning, the ensemble methods and the analytics techniques. So in deep learning we have the neural network, like you have, suppose I provide you with n number of different sources and there can be further metrics to drill it down. Suppose I tell you the time, but to the time there is am pm, then there is further lower drilling down to days and weeks, like weeks, days, hours, minutes, seconds. So the layer of challenges that can come to you, okay, and how you go for handling them through the neural networks. In the same way, there's ensemble methods, basically a combination of our traditional approach and the uh, AI models that we are creating. So, how supervised and unsupervised learning goes hand in hand. We go for random forest with gradient boosting integration. Okay, how we go for optimizations and how we basically govern multiple algorithm. We put multiple combination of algorithm together and then work over them, like which one is giving the best optimized results for a particular problem statement. And then there are various analytics techniques like time series analysis, graph analytics. So time series means, suppose you are having a data today but it has to have a relation from the past. Okay, it has to have some kind of details being uh, pulled from how and what happened in the past and how it is being handled, right? So those time series analysis of tracking the patterns, how it is being dealt in the past and how it can go in the future, right? The trading platform, the share platforms, we go for understanding, right? We may go for making decision whether a share will go up or down based on the information. So that is also a part of time series analysis that we are doing as a human. Okay. Uh, so further, the future trends, what holds, basically the transparency is what is required. Okay, the federal learning implementation, and finally the quantum enhanced security. So whatever securities in today's time might not be sufficient enough to govern, okay, to handle what is happening and to basically make it beneficial for the end user, because a lot of things can be outdated. With the pace of AI, we need to better optimize and modularize each of these techniques so that best results can be taken out, right? So, what are the best practices? We ensure high quality and unbiased training data sets. We go for implementing robust data governance frameworks. So, if you have heard, Abu Dhabi government have decided to make it complete AI governance. So how that can help, that will eliminate the human inferences or interferences that happen, right? Any kind of wrong happenings that do no. Because we as a humans are having a emotional touch, or various kind of thinkings can come, but to these AI robots in place with what kind of AI model is being developed, they'll work as per the rules and regulations. So once a rule is made, needs to be applied for everyone, right? So that kind of data governance best practices and frameworks would be developed. okay, and to maintain the data privacy and security standards of high level, and perform the data lineage and audit trail, so that we are not sitting somewhere where we have no idea of what's happening and how it is happening. Instead, we have each and every follow up and track back system in place to understand how the overall data is present, right? Then the model development that we talked about, how it is being trained, tested. I tried to show you through the code logic as well how it is being run step by step. With time and with new data available, it will keep updating its own model. And then the operational excellence, like how well and better you can make it with the various cases being available. Okay, so that's the best practice. So I am now open to any questions, any feedbacks, any challenges that you guys faced, or anything, guys. So open to you guys. Any questions, any queries?
Hello, hello, sir. Hello. I
Yes,
am
sir.
audible, sir.
Yeah.
Yeah, sir. In
Sir, your
this
voice is not
development,
audible properly.
okay, sir. In this development implementation strategies, first there will be AI development and then the ML, na? Sequence. Hello.
Sorry, I couldn't get you. Can you repeat?
Implementation sequence. There will be first AI development and AI model development and then ML, right?
Yes. So first, so there are various algorithms. Data structure is something of utmost importance. Okay, how the data structures and what algorithms are used in place. So we have these AI models being trained over with the different data. Suppose you are starting today, but there are encounters from the past, like people are training and testing these models in the open source platform. And then basically after that, once you train and test your model, you feel the efficiency and the results of model are good enough to send it in the production environment or in the real time. And then further machine learning is basically you will keep training your models with much better optimized outputs. So yes, AI and ML, they'll go hand in hand. Yeah.
Okay. Thank you.
Any queries, sir? Anyone? Any issues? Any questions?
So, Pulkit Gupta, good evening. I'm Ganpati, professor.
Hello, sir. Good evening. How are
Yes,
you?
very interesting. Your point of view on AI banking solutions. You have given good. I am asking you
Thank you
now.
so much.
Yes, yes. Now
Yeah.
our nationalized banks actually more they are using blockchain because of the
Mhm.
transparency. So how do you think, since you are a developer and a, implementer, how do you think actually blockchain whether it may go a little bit more since our government is
Block.
very interested in digitalization, most of the
Ye-
transactions. So
yes.
how
So
do you
blockchain may. Yeah. Yes. Yeah. Please complete, sir. Yeah.
okay, please go ahead. You tell the thing. Actually, I want to know your perspective.
Yes, sir. So blockchain basically for Bitcoin mining, right? So as of now, it is not in heavy trend in India. If you
Yes,
talk
yes,
in
you're right.
terms of India, the Bitcoin, they charge heavy, what I should say, heavy taxes on them. So it's not as regulated. And in India's perspective, it was trying to avoid it, but in the global perspective, since it has become unavoidable, I have, on the personal perspective, I've come across people who have been in earning and investing in the Bitcoin like
Yes.
anything, each and every of their savings. So if Bitcoin goes down, they are
Absolutely.
poor, and if it goes up, they are millionaires and even billionaires. So
Yes.
it all depends on time and efforts. And because it's a virtual currency, and like if you talk about blockchain, it's not in control right now for anyone. So even when we talk about the various coins and further the blockchain techniques being applied, right, they are working on already developed coins that are there in place. So there have been a fraud issues also that happened, or overnight companies have come and gone away. So it not a very concrete as of now, but more and more regularities as the government bodies come in, they regularize it, and they allow it and authenticate it as a transactional value, how they are dealing in gold and silvers, right, or dollars and rupees. Same way, once that is being approved, then it would be of much more use, because transaction happening can happen very fast.
And
And
transparency, high level transparency.
yeah, but very huge amount of transparency is required, sir. As of now, it's even though it's growing, but it's risky until and unless proper governance is in place.
Okay, sir.
My
And it may
personal
come. It may come at some time or other. Definitely.
it may come, and with AI in place and more optimizations and engineering being improved, so it should be very fast, I suppose. And very soon you can hear Bitcoin parallel to gold and silvers being in place.
Okay, sir.
Yeah.
Thank you very much, Mr. Punkit Gupta.
Thank you, sir. Thank you. Any other queries, sir? Any questions, anyone? Any feedbacks?
Dear participants, you can ask questions.
Sir, for dealing with multi-data sources in bank, how you are joining the data based on some Aadhaar card or any some customer ID like that?
Uh, I'm not very clear of the question being heard. What I understand is how you are trying to understand how the customer's data is being identified, and like for a particular customer ID, how a particular transaction is happening. That's what you are trying to understand, sir. Okay. So what happens is, on the front end, right, for you as a user or me as a user, not as a developer, so we have applications being developed and created in the front end. The websites being developed in the front end, and full stack developers are there in place who go for creating applications which give you a C360 view, the customer 360 visibility of what is happening, what transactions a particular am I audible? Yeah.
Yes, yes.
Yeah, what transaction a particular customer is doing, whether he has a requirement of loans, whether they are having the insurances being taken from any bank, okay, whether there is a how is there any CIBIL score impact, whether your transaction is not up to mark or up to the mark, how are you maintaining your transaction, so that complete visibility. So in today's time, every person is governed on the complete 360 profile of, like, 360, I mean every nook and corner of what they are doing on the transactional front, on the digital platform, is being governed and monitored, and that makes bank more secure to handle what is happening and what's not happening for a customer. Answers your question, sir? Any other queries?
Please ask.
This, just wanted like now I'm audible, sir.
Yeah, yeah,
Yes,
you are audible. Yeah, please go ahead.
a little bit of disturbance.
How? So there is a customer. Uh, in two banks accounts are there in Dena Bank and some other bank. So they have some data can be joined using other ID or some parameter is there for joining the data integration purpose in multiple sources.
You have Aadhaar card and PAN card in India, right, sir? So basically,
Yes.
on the RBI front and on the ITR front, they like bank will not share the data in general, but what I think of in the terms of RBI and ITR, right? They are accumulating your overall transactions, bank accounts, and IDs. ID here would be your PAN card and Aadhaar card that is being attached to each and every bank account without any exceptions, right? So that's how every candidate is being tracked, being it any number of bank account doesn't matter.
Thank you, sir. Just I wanted to ask that data integration happens on common ID or customer ID. That's what. That's
Yes, so yeah, on depend on like banking level, customer ID. On the higher level depends on different ID or primary key value, you can say in technical term, which basically solidifies the record.
okay. Thank you so much.
Thank you.
Mr. Gupta, can you just take your slide to the first slide? I need to take up a screenshot of it.
Sure, sir. 1 second.
Presentation to the first slide.
1 second, sir. Uh, yeah, visible, sir.
Yeah.
Any other queries, guys? Okay. I have a question. Uh, how can we ensure customer privacy when using the AI? So, customer privacy. Okay. So, these models that we develop, right, the data is being generally masked and not visible to individual eyes in general. So when we talk about customer privacy in AI, so AI is basically working on some values that are of importance. Okay, what is a privacy data? It has to be masked and then processed in the AI models. Okay, not everything has to go. There has to be regulatory functions, and there has to be regulations in place to decide what to go and what not to go. uh, Miss Nirmala, I hope I answered your question. Dr. Subhas, how does AI help prevent fraud? So, all details that we talked about, right? How, what is your sitting posture? What is your moving posture? In what tone or language you are talking? Whether someone talking in front is a AI robot or a real person. So, all those frequency and analysis depends on what kind of data it is being trained and tested by. So depending on the data quality, it all depends like how quickly it is able to prevent that fraud from happening. Okay, suppose the transaction, you are sitting in India, your location is India, your card is in India, and it is being transacted in US, then that raises a concern. So such kind of issues are being alerted to the customer as well as to the banking sector. Any high value transaction we do nowadays is being governed and monitored, and we get a mail or notification. If it is not, you stop right away, right? Such kind of notification comes, and that's how it helps in better fraud prevention and better organizing of and handling of the data, like overall issues and fraud issues. uh, Dr. Subhas, I hope I answered your question. Anything else, please?
Are there any other queries? Are there any other queries, please? Okay, so I guess we should now end this session. This was our second last session. Thank you so very much, Mr. Pulkit Gupta, for being with us. Thank
Thank
you.
you. Thank you
Thanks a
so
lot.
much, sir. Thank
Thank
you.
you
Thanks for the wonderful opportunity and the great audience. Thank you, everyone.
very much to be at the Atal FDP. Thank you.
Thank you.
So now, thank you, sir. You may leave now. Thank you, sir. Thanks. Now we have with us, will be joined very soon within the next 5 minutes of time. We'll be joined up with Dr. Shubhrajyoti Kundu, right? He is basically electrical engineering PhD from NIT Durgapur, and there is a area which hasn't been touched yet, and that area is how we can adopt data handling, specifically unstructured data handling, in the area of core sectors like electrical engineering or some other. So we thought of having data handling in electrical engineering. He will be joining with us soon, and he will be our next speaker for this session and for the last session. Now we have got hardly 5-6 minutes of time left. Let me tell you that immediately after this we'll be having our valedictory session, and after the valedictory session we'll be having our this quiz, a small test of around 50 MCQ that will be given to you via Google Forms. You have to give the examination. It's a very easy one. Don't worry, don't get panicked. You just have to sit back and give your examination. But there are some mandatory requirements. If you have got any sort of problems, you can ask me now. There are some mandatory requirements. I have already posted it in the WhatsApp group. The mandatory requirement is that you have to give the test via The only mail ID that is there in your portal by which you have registered it, by which you log into your AICTE portal, right? The email that you use for your Atal portal, you have to use that only. Since you're not responding here and this is getting recorded, I will take it as granted that you have understood this. You have to give the test only by using your registered email ID that is there in your AICTE Atal portal. If you're not doing so, I am helpless. I am sincerely helpless. Right? I cannot help you out. It is a mandatory requirement. You have to give the test in the Google Forms by noting down, and you have to also check that the email ID that is there on that top, it should be your registered email ID that is there. Whichever email ID you have registered in your Atal portal, only that email ID should be there, right? We cannot, we don't have the option other than that. We have to sort it out, right? So please be there with that email ID only. Under any case, attempt all the questions. There are 50 questions. You will be getting around 30 minutes of time. But after this session, you'll be having the valedictory. We'll be having a short valedictory where we'll be of 30 minutes around. That means this session will end at around 6:30. 6:30 to 7, we'll be having the valedictory. From 7 to 7:30, we'll be having the quiz. And we will have an ending of this AICT Atal FTP. So if there are any sort of queries, you can ask me now, because immediately after that we'll start up with the valedictory, and immediately after the valedictory the link for the test will be sent to you over email as well as on the WhatsApp group. If you've got any sort of queries, you can ask me here. Don't ask it on the WhatsApp group. If you're asking on the WhatsApp group, means you are not here, right? Please ask me. Okay, so just be there for the next 2 3 minutes. We'll be joined up with Dr. Shubhajyoti Kundu.
Excuse me, sir.
Yeah, ma'am, please.
Sir, actually, I have attended other Atal FDPs too, but there on that FDPs, I have given the test on the portal, Atal portal.
No,
So
not
you will
always.
provide the
Not
Google
always.
form or
No, Google Form. The last FTP that I joined, they had that also. I had joined around 85 Atal FTP programs. It is both way options are there, Miss Rakhi Sharma, Dr. Rakhi Sharma, whatever. It's there now.
okay, thank you, sir.
Banerjee sir, I have a question. Am I audible?
So just wait for a few minutes.
Banerjee sir, are you there?
So we have with us our next speaker, Dr. Subrajyoti Kundu. As I said, he is currently a faculty at Paul University at Baroda, in Gujarat. He is an alumnus of the Department of Electrical Engineering and IT Durgapur. We'll be talking about the area of data handling in electrical engineering. Sir, now it's all yours. Dr. Kundu.
Yeah, thank you, sir, for your kind words. So I will be starting my session. So
Yeah,
just
please, you can share your screen.
yeah, yes, sir.
Yeah, you share and then wait for a few seconds. We'll be taking a screenshot of that. Please do share.
Okay, okay. Yeah, yeah, yes, sir.
Please do share the screen, sir.
Yeah, yes. Is it visible, sir?
No, no, no. Yes, I hope. Just a second.
Yeah.
Yes, now it's visible. Just a second. Be like this. Yeah, you can start now.
Okay. So basically, the topics today's topics of discussion is data handling in electrical engineering. So So basically, first of all, what is data in electrical engineering? So basically, here I will discuss data in power system. Now, first I will tell what is power system. So basically, see power system. You can see it is a core branch of electrical engineering, which it mainly focused on generation, transmission, and distribution, and utilization of electrical engineering. So basically, whatever I will discuss today that will be the data that is based on power system. So in power system there are so many data that power system generate huge amount of data, and why this data are so much important in power system. So basically this data are required for monitoring purpose, control purpose, protection purpose, and optimization purpose. Now what are the sources of this data, means how from where we can get those data. So basically, the sources of this data are mainly like SCADA, that are installed at various substations. Next is PMUs, that is phasor measurement units, along with some smart meters are also there, and IoT sensors are there. So basically, we can get those data, or you can also say measurement from this measurement. These are particularly the measurement device which actually provide us the data for doing the rest of the applications like controlling, protection, and optimization. Now, what are the different types of data in power system? So basically in power system here, my topic of discussion today is mainly related to measurement data here. So there are various types of measurement data we can get from either SCADA or phasor measurement units. So first of all, it can be voltage, where we can get the voltages at bus and also along with the phase voltages. Along with that, we can also get the current like line currents and load currents. And next is we can also get the frequency information from PMU, that is phasor measurement units. And after that also we can get reactive power, active power, different types of power. This information data we can get from those devices like SCADA and PMUs. Along with that, we can also get some other information like harmonics, flicker, interruptions, sag and swells in voltage. So these are some of the type of data that we can get as a measurement data in power systems. Now, how this data are collected? So basically, see, there is a layout here has been given. So here, these are the phasor measurement units. So that is actually a device which is actually collecting which is actually providing the data. Now, these phasor measurement units, that all these phasor measurement units are placed in a substation in the power system. Now, each of these PMUs, they will provide some data like information like voltage or current to a concentrator, which is called as a data concentrator. And similarly, there might be more than 2, 3, 4, 5 data concentrators. So all of these data concentrators will collect the combined data from various PMUs. Like in this figure, you can see there are 5 PMUs have been installed for each of the substation. So from this substation, this data will be transmitted to the data concentrator. And now after this transmitting the data to the data concentrator, these data concentrator will transmit the data to the final super data concentrator. Now, in this way, the data has been collected from PMU to data concentrator. We also call it as a PDC, that is phasor data concentrator. So this is the process in which we can collect the data from PMUs and then transmit it to the central PDC. So basically here you can see this is the central PTC. Now these are the these are also data concentrator, which is actually combining the data of all the PMUs, and finally that it will send to the central PTC. Okay. Now, how this data, which we are collecting from either SCADA or PMUs, how this data we are validating. Now, in order to validate this data in power system, we are using a mechanism, and that is called state estimation. Okay. So, what is actually state estimation? So, and what is the purpose of doing the state estimation? Because see, actually, whatever the data we are getting from that PMUs or SCADA, that data is actually not a pure data. That data will consist of noise, because that is actually from the previous diagram you can see that these PMUs are actually transmitting the data to the data concentrator, and that transmitting of data, that is through a communication channel, and in order to transmit the data to the communication channel, there will be some presence of noise. So whatever the data we are getting in actually in power system, that is actually consist of noise. So that is the purpose of doing state estimation. So what is actually state estimation is doing here? So state estimation is actually filtering those data, means that is it is actually reducing the noise that is present in that measurement data. So the basically the definition of state estimation is, it is actually the process of determining the states of power systems, like voltage phasors at each bus. And for that, for in order to calculate that voltage phasors, we have to utilize the measurements like data which we are collecting from the PMUs or SCADA. So that we can get a much more good version of the power system states, that is voltage, magnitude, and phase angle. Now, once these voltage phasors are known to us, now these known voltage phasor, that can be further implemented in other power system operation like economic dispatch and control. So that is the importance of performing state estimation. So basically now the state estimation process in that is actually we are doing for validation of the power system data. Now the state estimation process can be classified into mainly two types. So first one is static state estimation, and second one is dynamic state estimation. So practically, what is static state estimation? So practically, static state estimation is like that. You are collecting the data from the measurement device like PMUs and SCADA, and you are calculating the estimation at the current timestamp. Okay, like that. Suppose you can consider the example like that. Suppose it is like a photography. So if you are taking a photograph, that means it is related to a particular timestamp, like that. So basically, static state estimation is like that. And on the contrary, dynamic state estimation is different from static state estimation. Now, dynamic state estimation you can compare with like doing video recording. Okay. In case of hello. Is there any doubt?
No doubt.
So basically the dynamic state estimation, that is different from the static state estimation. In dynamic state estimation, we are collecting the data suppose at a particular timestamp. We are collecting the data suppose at a particular timestamp, and then we are calculating the state for some other time samples. Like, so you can consider it like as a video recording like that. And where static state estimation is like a
हाय मम्मा म्हणजे आता कुठून गेली अरे खूपदा गेलेली आहे पण सिग्नल मोडून जायची इच्छा आहे कसं कसं करावं तुला सिग्नल लागलं
is
आता
there any doubt there? So basically, dynamic state estimation is basically providing the estimated state at the current time sample, or as well as it will predict the future state. Okay, by considering the measurement data that we are getting at the current time stamp. Suppose if we are considering right now it is 5:10, so we can get the current estimation at that time. Along with that, we can also get the predicted state or the next time sample. Suppose if we consider 1 hour as a time sample, so we can also get the predicted state at the 6:10 like that. So that is basically dynamic state estimation. So basically here some mathematics are given here. So for traditional static state estimation, where Z, this is actually the measurement data which we are either collecting from SCADA or PMU like that. Okay. And this is basically the estimated state which we will get after performing the state estimation. So that is actually this value means this estimated state that is actually reducing the noise which is present in the data that is we are getting from the measurement device like PMU and SCADA. So here some mathematics it is given here. So how this is solved? So basically this is actually the final result. So this means this equation 6 that is actually telling that what will be our estimated state. Okay. So in this way, we can apply this process to calculate the estimated state at the next time sample. So k plus 1, here it is the next time sample, and where k is x of k, this is the state at the present time sample, like k. Now, this is the traditional extended now dynamic state estimation algorithm that can be majorly solved through a traditional extended Kalman filter based algorithm. So unlike static state estimation, which we have seen in the earlier slide, dynamic state estimation, it consists of two steps. So first is filtering step, which is can be given through this equation 7. And next is the prediction step, which is given through this equation 8. So first of all, already I told you that first of all, with the help of the measurement device, we are collecting the data, and with the help of this data, we are first calculating the predicted state for the next time sample. So that is basically the predicted state for the k plus 1 time sample. And this is actually this j of k, this is actually the data that we are collecting from the PMUs at time k. Okay. And this is what is this thing? This is actually the noise, because already I told that whatever the data we are collecting, that is not a pure data, that is having some noise. So this is actually this eta k that is actually representing that noise which is present in the PMU data or either SCADA data like that. Okay. So here some mathematics is given to in order to represent that noise. Okay, like for here eta k, how it is represented in terms of mathematics. So here it is given. Now first is filtering step. So the filtering step is finally solved through this equation 14. So that equation, that means this x k by k, that is actually giving the final results, means the estimated states. And this is actually the predicted states that we are getting by doing the prediction of the previous time instant. Okay. And with the help of this Kalman gain, so Kalman gain is calculated through this equation, as you can see in equation 15, we can finally get this estimated state. Okay, so that is basically the filtering step. And what is the prediction step? Now the prediction step, with the help of this estimated state at the kth instant, we can get the predicted states for the next time instant, that is k plus 1 time instant. And similarly, we can also get the prediction error covariance matrix with this equation 18. Okay. Now there is a approach to in order to doing this static state estimation and dynamic state estimation, and also here some discussion regarding bad data has been considered here. So I will tell bad data later, but first let me discuss what is this NSSE, that is Nobel Static State Estimation Scheme. So basically here it is represented, the measurement model is represented through this equation 19, where Z is the measurement vector. Okay, measurement vector, that means measurement data. And this is we are collecting from the PMU. And this is consist of two type of data. So first one is IL, which is basically the currents, line currents, and VB, which is basically the bus voltage. So these two data we are collecting from the PMUs. And this is all the noise. Already I explained what is the noise, because this data is actually comprising of noise. And this is the estimated state that we have to obtain. So V is the estimated state that we have to obtain by performing the statics, by performing this estimation algorithm. And this lambda is actually representing the relationship between this measurement data and this estimated state. So here in this NSSA scheme, we can calculate the V by directly applying this formula. So that is actually the estimated state. So here you can see Z is actually the measurement vector, and psi of inverse, that is actually the error covariance matrix, and we can get the error covariance matrix from equation 22. Okay, next is lambda transpose. So lambda is that matrix, already I have explained here. So that is consist of these two submatrix, lambda 1 and lambda 2. So by using this equation that is shown in 23, we can calculate the estimated states V, which is comprising of complex bus voltage vector. And the gain matrix can be calculated, as you can see in equation 24. So this gain matrix we have to incorporate it here to in order to finally calculate the estimated state V. So here the flowchart of the proposed NSSE scheme is given here. So as you can see, it is shown here what are the process. So first we are collecting the data from the PMUs, okay, and next we are feeding that data to the state estimation algorithm. So here this is your data which we are collecting from the PMUs. And in that process, say we are also correcting the data which is a bad data. Now what is a bad data? Say suppose some of the data which we are collecting from PMUs or some other device, that may be much more deviated from its actual value, like and that may happen, suppose if some of the device may become faulty, or some of the device may get disconnected to provide data, like that. So in that case, whatever the data you are getting, that will be a very poor data, and that will be actually deviated from its actual value. So that type of data we call it as a bad data. So first we are detecting, identifying, and correcting the measurement which comprises bad data. So suppose in our data set, if some of the data is comprising of bad data, then we are detecting first, then identifying which data is a bad data, and then we are correcting the data so that we can give it to the state estimation algorithm. Now next is the other dynamic state estimation approach. So basically previous one is the static state estimation approach, and this one is the Nobel dynamic state estimation approach. So here in this case, this algorithm has two steps. So one is filtering step and another one is prediction step. So the filtering step is solved through, first we are defining the measurement model here. So already I explained that this is the measurement vector which we are getting from the PMU, and V is the estimated state that we have to obtain. And this equation is the final equation for, basically here we are applying optimal Kalman filter. Okay, so in order to get this estimated state at kth time instant, and this is actually the predicted state, because already I told that dynamic state estimation means there will be two stages. First one is prediction stage. So by doing prediction stage, we are getting this predicted states, and then we are getting the estimated states. And these are the Kalman gain matrix, which is calculated through equation 27, as you can see. Okay, and the filtering error covariance matrix can be calculated through this equation 28. So And now this is the prediction step. So the prediction of the voltage for that particular next time instant can be calculated through this equation 29. Okay. And for that purpose, we have applied a smoothing approach, that is Brown's triple exponential smoothing approach. And that approach can be used for any type of forecasting. So here actually we are doing forecasting or prediction. So for that purpose, we have applied this Brown's triple exponential smoothing approach here in order to calculate the predicted states for the next time instant, that is k plus 1 time instance. So here the mathematics of that Brown's triple exponential smoothing approach is given here through equation 32 to 38. So by finally equation 38, we can get the predicted states for the next time instant. So this is basically the flowchart of the proposed novel dynamic state estimation algorithms. So again, we are collecting the data from the PMUs, and again we are detecting, identifying, and correcting the measurement data set which is having some bad data. And after correcting the data, we are giving this data to the estimation algorithm. So basically, this is the data which we are getting from the PMU, and after that we are correcting that data. If that data has some kind of means if that data is a malicious data like that, so that we can give the good data to the estimation algorithm, and finally we can calculate this estimated state by using this equation. So now there is a bad data processing algorithm that we are incorporating here. So basically already I explained what is bad data. Now instead of eliminating the bad data, here we are actually correcting the bad data so that it can become a good data and it can be fed to the estimation algorithm. So here, the first of all, the normalized residuals are calculated. Now how the normalized residuals are calculated? So first of all, the estimated residuals are calculated through this equation 40. So basically Z is the measurement data that we are collecting, and V is the estimated state. So that is, this processing is actually being performed after the estimation. So here already we have got this estimated state from the previous discussions, like whatever we have got like that. So here this estimation already we have got. Now this we are putting in this equation 40, and we are calculating the estimated residuals. After that we are doing some normalization by using this mathematics, as you can see in equation 39, where this P cov is the residual covariance matrix, and this can be calculated through this equation 41. Now in this case, if this normalized residual, in general, if this absolute value of this normalized residuals, if it is more than 3, then we are taking assumption that it means that data is a bad data. That means that data is actually deviating, much more deviating from its actual value. So in that case, we have to make that data as a good data so that we can give it to the state estimation algorithm. So basically the correction of bad data here, it is performed through this equation 42, where this ZB corrected, that is actually the corrected data, corrected bad data. So, and by using this mathematics, we are correcting the bad data. And after correcting the bad data, this this corrected data is being fed to the state estimation algorithm as discussed earlier. Now, there might be some, apart from bad data, there might be some condition in power systems or in electrical engineering that there might be some sudden change in the load. So in that case, the residuals which we have earlier calculated, so that may also become higher or greater than 3 in case of sudden load change. So in order to discriminate that, we are using an asymmetry index. So these mathematics will have been used to discriminate the sudden change of load from the bad data. So if the index, if it is more than a pre-specified value, then the anomaly is due to bad data. And if it is lying below some below some threshold, that means the sudden load change could be the reason for that anomaly. So basically some simulation results are shown here. So this approach has been tested on several IEEE test systems, and also 2 Indian practical test systems have been considered. So one is Damodar Valley Corporation 38 bus system, and another one is Northern Regional Power Grid 246 bus system, both under normal condition as well as considering the situation where there is a presence of bad data. And for that, doing the simulation, the load variation have been considered using a process which is described in this reference 41. So basically in this reference 41, we have based on this reference 41, this particular week has been chosen, which has a 73.7% load demand of the annual peak demand. And Monday has been selected as a particular day, which has a 93% load demand of the weekly peak load. And the loads are assumed to have a constant power factor so that the reactive power is actually following the active counterpart. Okay. Now here, how the data have been generated, that is been discussed here. So first of all, the load flow have been conducted to get the true value of the state at each time samples. But this is actually the true value. But how the measurement data have been generated here. So after obtaining the true value, this true value are incorporated by a normally distributed error function. That means we are adding some Gaussian noise, which is having a white Gaussian noise, which is having a mean of 0, and the standard deviation that is considered is 0.5% of the true value. So by adding this normal Gaussian noise to the actual value which we are getting from this load flow, the PMO data or measurements have been generated here. Now here in table 1, the how the bad data have been selected, that has been discussed here. So it is shown here in this table 1. So here in this table, which are the bad data that has been considered here. So these for different system, for different test systems, different bad data has been chosen. Like for if we consider this one, so in this case it has been chosen that at 12th time sample. So basically here time sample means you can consider like hour. So basically at 12th hour, this line current, so basically this is a current, I here it is representing the current. Now current between what? Current between two different bus, that is bus number 9 and bus number 40. So in that data, whatever the data we are getting from the PMO, in that data some means that data is not a good data, means that data is deviated largely from its actual value. So that is a bad data. Here we have considered that one as a bad data. Similarly, for here also these are the bad data at different time sample considered. Similarly, for other test systems like IEEE 3057, IEEE 118 bus, along with two practical system. So this is Damodar Valley Corporation 38 bus system, and this one is Northern Regional Power Grid, okay, which is of a 246 bus system. So for different bus systems, these are the bad data that has been considered in order to highlight the performance of the algorithm under anomalous scenario. Okay. Now some performance evaluation parameters have been given here to highlight the accuracy of the proposed algorithm. So here for filtering step, this is average absolute filter state error, which can be obtained through equation 44. Next is performance index, which is can be obtained through equation 45. Okay. So basically here, this is the estimated state, this VEI k by k at kth time instant, and this is actually the true value. So basically here this expression is calculating the deviation between the estimated state and the true state. So basically here state means voltage magnitude and phase angles. Similarly here by using this mathematics, the J index, or the we can also call it as a performance index, that is being calculated. Some other performance evaluation parameters have also been selected, like maximum absolute filtered state error. Okay. Next, for prediction step, in order to highlight the accuracy of the prediction step, these mathematics have been chosen, that is maximum absolute predicted state error. And along with the performance evaluation parameter, some statistical parameters like for filtering stage, that is maximum mean square error, that has been also been considered. Next is maximum standard deviation error, maximum sum squared error, and another parameter that is average absolute error. So these type of statistical parameters have been considered in order to highlight the accuracy of the proposed algorithms. Similarly, for prediction stage also, the statistical parameters have been calculated in the similar way, like discussed in the for filtering state. So here some results have been given in order to highlight the accuracy of the proposed algorithms. So basically, see, this is the time sample which is shown here. So like it is the fourth time sample, sixth time sample, like that, up to 24 hours it has been chosen. Now this is actually the real power which is we are plotting with the time sample, and this blue one, that is actually the true value. So here it is the true value, and the other algorithms, like whatever they are getting by doing the estimation, that is being shown here. Now from this figure we can see that these two are the proposed, like NSSC and NDSC. Now they are giving comparatively better result comparative to the comparatively in comparison to the traditional SSC and the extended Kalman filter based dynamic state estimation. Similarly, in figure 4 also, reactive power has been chosen in order to highlight the accuracy of the proposed algorithm. So here you can see that the proposed, this one is your true state, true value, that is shown in this blue color, and the NSSC and NDSC, that is actually overlapping with each other. So that's why both are giving the same result, the NSSC and NDSC, and both are giving good results compared to these two algorithms, that is SSC and EKF. Similarly, in this figure, that is figure 7, the maximum absolute filter state error that has been calculated for different time samples. And for the test system considered is IEEE 30 bus test system. So from this figure also it can be observed that uh, these proposed algorithms, that is NSSC and NDSC, they are giving less amount of error compared to other two approaches, that is static state estimation and extended Kalman filter algorithms. Similarly, here in figure 8, a comparison of average absolute filter state error for IEEE 14 bus test system has been given here. So here we can see that in case of uh, other algorithms like SSC, this is for SSC. So in case of SSC, the average absolute filter state error is much more higher compared to these proposed algorithms. Similarly, in case of extended Kalman filter, which is shown through this dotted green lines. So here also we can see that this is giving comparatively inferior results compared to this proposed algorithm, that is NSSC and the NDSC. Now NSSC and NDSC, again it is showing that they are being overlapping with each other, means they are giving the same estimated states for each of the time samples. So by using these figures, we can say that the proposed approach, that is NSSC and NDSC, they are actually handling the data much more better comparatively to other two approaches, other two conventional approaches, that is static state conventional static state estimation and traditional extended Kalman filter based dynamic state estimation. Now some statistical parameters, it has been shown in this table. So here for each of the test system, different methods have been given and calculated for each of the test system. So for IEEE, if we consider an IEEE 14 bus test system, then we can see that the NSSC and the NDSC, that is actually giving the less amount of error. Okay, like if we consider these statistical parameters, which is maximum mean square error. So you can see that these two are giving the same results, and both are giving comparatively less statistical errors compared to the traditional SSC and EKF. Similarly, if we consider the other statistical parameters like maximum standard deviation error or maximum sum squared error, average absolute error. So in all these parameters, statistical parameters, we can observe that the proposed NSSC and NDSC, they are actually giving less amount of errors compared to the other two approaches, that is SSC and extended Kalman filter. Same type of results can be observed for other test systems like IEEE 30 bus system. So if we see in case of IEEE 57 bus system, we can see that here the maximum mean square error is this value, okay, which is much more lesser comparatively to this two value. Similarly, for other parameters, this value is less compared to other two values that has been obtained through SSE and extended Kalman filter. So basically, some other results for other larger test system like IEEE 118 bus test system that has been also been given here. So in all the test systems, we can see that this NSSE and the NDSE, they are actually giving less amount of error. That means they can this by using this type of state estimation, we can handle the we can validate the data much more better comparatively to other two approaches, that is SSE and EKS. Similarly, for the practical system also, like these two are the practical system, DVC, Damodar Valley Corporation 38 bus system, and Northern Regional Power Grid 246 bus system. So in the case of practical system also, we can see the proposed algorithms, that is NSSC and NDSC, they are giving less amount of statistical errors, which actually suggesting that this type of estimation algorithms can handle the power system data much more better comparatively to the other two conventional approaches. Now in this table, the statistical parameters have been calculated. The same statistical parameters have been calculated, but here the states that is considered, that is the predicted states instead of the filtering states of the estimated states. So here for different test system results have been produced here. So for IEEE 14 bus test system, we can see that among the two other forecasting methods, so these two are these three are the forecasting methods here. So basically, this one is HTP, that means holds two parameter smoothing used to forecast some data. Next one is Brown's double exponential smoothing approach, and this one is the proposed approach, which is Brown's triple exponential smoothing approach. So if we consider the test system of IEEE 14 bus system, so we can see that Brown's triple exponential smoothing approach is giving the better amount of results. That means you can see here it is giving the less error comparatively to the other two approaches for all the statistical parameters. So we can say that the Brown's triple exponential smoothing approach can much more is better for doing the forecasting. Okay, so that this method is actually is used in conjunction with the Kalman filter, which I have discussed earlier. So basically, this is used because this is actually being better comparatively to other two forecasting approaches. Similarly, for other, if we see the results of other test system like IEEE 30 bus system, IEEE 57 bus system, along with larger system like 118 bus system, and also if we see the practical system, then we can see in all those systems the proposed approach, that is this Brown's triple exponential smoothing approach, this is actually giving the less value of the statistical parameters, which actually suggests that this method is suitable in order to be applied with the Kalman filter, so that we can handle the data, that is power system data, much more better in comparison to other approaches. So here some comparison has been given here through this figure. So here the predicted active power comparison at bus number 29 for this IEEE system has been shown here. So basically this is actually the true value which is shown in this blue color line. Okay, and this one, that is the red color, that is actually the false two parameter smoothing approach, and this one is your Brown's double exponential smoothing approach, and this one is the proposed approach, that is Brown's triple exponential smoothing approach. So basically you can see in most of the time samples that this approach is giving much more closer value to the actual true value. So from this we can suggest that this is better or superior in comparison to other two approaches, that is Holt's two parameter and Brown's double exponential smoothing approach. Similarly, reactive power comparison for at bus number 191 for a practical Northern Regional Power Grid 246 bus test network is also shown here. So here also you can see that uh, throughout the time samples, this Brown's triple exponential smoothing approach, this is actually giving the better results comparatively to the other two smoothing approaches, which are used for forecasting or prediction of the state. Okay. So again, here in this table 4, the statistical parameters considering the predicted states have been shown here. So if we consider all the test systems from IEEE 14 bus to larger system like 246 bus system. So in all the cases, we can observe that this proposed approach, which is highlighted in bold color. So here you can see they are giving this Brown's triple exponential smoothing approach, that is giving the less statistical errors comparatively to the other two methods like HTTP and BD. So if we consider the IEEE 14 bus, we can see here we are getting this value, okay, like 0.000068, which is lesser than these two values. Okay, similarly for other statistical parameters, we can see that these statistical errors which we are getting from this Brown's triple exponential, that is much more lesser comparatively to the other two forecasting approach, that is holds two parameter as well as Brown's double exponential. So now some cases have been considered in order to highlight how the algorithm is working in case of the presence of bad data. So already I explained what is bad data. Now, if there is a presence of bad data, now how these algorithms are working, that is being highlighted in this figure. That is figure number 30. So here, the J index, which the mathematics is already I have shown in the previous slide. So here, this J index have been calculated for the both the algorithms, that is NSSE and the NDSE, and the test system here is shown, that is IEEE 118 bus test system. Now the situation here considered is that the data we are collecting, then in that data we are assuming that there is a presence of bad data also. Okay. So how these algorithms are handling the bad data, now we can see from this figure. So here, this black one, so black one is actually, first of all, see this blue color one. What is this blue color one is suggesting? That means it is suggesting that without bad data processing algorithm, that means the data whatever we have got from the device, that is actually consists of bad data, and without correcting the bad data or without deleting the bad data, we are directly feeding the data to the estimation algorithm. So in that case, see this value, it is becoming higher. Now, if this value is becoming higher, that means if the J index value is becoming higher, that means actually it is suggesting that your estimation is becoming poor. So in that case, whenever we are see this situation, this is one situation where there is no bad data processing algorithm incorporated in the state estimation algorithm. So in that case, we are observing that it is the estimation is becoming very much inferior, because that is this value is rising, and which is actually suggesting that the estimation we are getting, that is very much deviated from the actual value. That means the error is much more higher. Similarly, for this 12 instant, we have noticed this one. Similarly, for 18 time instant also, where also we have considered the presence of bad data, there also we can see that the whenever we are not using any bad data processing algorithm, in that case also we are observing that the J index value is becoming much more higher, which is actually suggesting that the error is being much more higher, means actually the estimation we have got, that is very much inferior. Okay. Now come to this one, that is red one. Okay, so what is that is actually the condition here. So that is actually with bad data detected, identified and eliminated. That means in this case, the bad data processing algorithm is there, and the bad data processing algorithm, that is actually what it is doing, actually it is deleting the bad data from the data set. Okay, so whenever it is deleting the bad data from the data set, after that, that is being fed to the state estimation algorithm. So in that case, we are getting this value at this particular time instant. Okay, and for if we consider the proposed scheme which we have discussed, that is this scheme is whenever the bad data processing algorithm is there, and that is actually first it is detecting the bad data, and after that, instead of deleting the bad data from the data set, it is actually correcting the bad data. That means it is actually making the bad data to a white data, so that it could be a good data, and in that case it can be given to the estimation algorithm. So here we can see this is giving the much more better results, because decrease less value of j index means the estimation is much more better comparatively to the other two case. And here also in you can see that here this no red line is there, because that is one problem considering this situation. Because instead of, in case of if we are deleting the bad data, in that case what may happen, the measurement data set that we are using, that may become less, and there should be a particular dimension should be there, matrix dimension should be there in order to perform state estimation. So if your matrix dimension is becoming less, in that case it may not be possible. So like here we can see for particular this time samples, for 18 time samples, we can see that we will not be able to get any value estimated state from this condition, because in this case we have deleted the data from the data set, so that we are not able to perform the state estimation. That's why we are not getting any value for, that's why this red line has not been shown here in the 18 time sample. So in this way, the proposed algorithms, that the proposed NSSC and the NDSC, can handle the presence of bad data in the data set. Now here the computational time for various algorithms have been given here for all the test system, from the starting from the smaller system to the larger practical system. So basically we can see that the proposed algorithm is much more slower compared, means much more faster, because they are giving less amount, they are taking less amount of time comparatively to the other two approaches, that is SSC and extended Kalman filter. Now, in the previous discussion, we have seen that we are using an algorithm that is NSSC and NDSC. Now, what is happening in case of the presence of bad data? We are observing that there is a presence of, whenever there is a presence of bad data, that means we have to use a additional bad data processing algorithm. Okay, so that will, what will happen if we focus on the previous discussions, then what we have seen that along with the state estimation algorithm, we are using an additional bad data processing approach. And in that case, what will happen, in that case, that will increase the computational time, because if we add more methods in order to address that problem, that will increase the computational burden. So in order to handle that bad data, instead of using a separate bad data processing approach like we have discussed earlier in the previous discussions, here we can leverage the bad data in power system by using a robust state estimation algorithm. So basically here now I will discuss a robust state estimation algorithm and how it is actually addressing the problem whenever there is a presence of bad data in the data set. Okay. So basically this FASC, that is actually a term that is forecasting aided state estimation. So basically that is nothing but a, actually that is almost similar to the term that we have earlier discussed, that is dynamic state estimation. So basically forecasting aided state estimation is a part of a dynamic state estimation. And basically here we are calling it as forecasting aided state estimation because see already I explained in the previous discussion that dynamic state estimation means we are first forecasting or doing the prediction for the next time sample. So that's why this type of state estimation can also be called as a forecasting aided state estimation. So here the problem formulation for the forecasting aided state estimation is given through this equation number 52 and 53, where this is actually the state that we have to calculate or estimate, and this is actually the estimated state at the previous time sample, and this is actually the function which is actually giving the relationship between the between these two variables. Okay, and this is actually the measurement model. So basically ZK, that is actually the measurement data like if we consider PMU data, so basically here we are considering PMU data. So that means this is actually the data that we are getting from the PMU. So that is basically a data vector, means this is a vector which consists of data from the PMUs, and this is the estimated state Vk, and this is the noise which I already explained in the previous discussion. So basically what we have seen in the previous discussion, that this data which we are getting, that is consisting of noise, because that is not a true value which we are getting. So that noise has been incorporated here with the symbol of this eta. Okay, and this psi, that is actually a function which is actually representing the relationship between this measurement data Zk and this estimated state Vk. So that is basically the problem formulation of this forecasting aided state estimation. Now the steps for performing this robust state estimation by using this square root unscinded Kalman filter, that is SQUKF, that has been discussed here. So first is the computation of sigma points. So basically these sigma points are calculated by using this mathematical equation 54, as you can see here. Next, there's some scaling parameters have been calculated through equation 55 and equation 56. Here some constant parameter gamma is being calculated by using this equation 56. After obtaining the sigma points, so basically sigma points are calculated through this equation, where the scaling parameter have been calculated through this equation 55, and the gamma has been calculated. Gamma is actually used in this scaling parameter. So this gamma has been calculated through this equation 56. Okay, and the value of zeta is considered as either 3 minus n or 0. Now what is n here? N is actually number of voltage or current, means number of states, means how many are the states. Suppose if we consider a test system like IEEE 14 bus test system, so in that case N will be 14, because here we are taking the data as a complex data set, means we are taking in the rectangular format, like in the form of A plus JB. So there means if we consider a 14 bus test system, that means we have 14 bus voltage, complex bus voltage. Okay, so in that case N will be 14, like that. And for other test system, like if we consider NRPG 246 bus system, in that case N will be 246, like that. So here basically the step is similar. Like first we are obtaining the prediction of the states. So first the states prediction have been done by using this equation 57. So basically here the sigma points are passed through a matrix which is called as a state transition matrix. So here it is shown here in equation 57, and after obtaining this sigma points which is being passed through these predicted states, next this prediction of the states have been performed. So this is basically this VKP, that is actually the predicted states. Okay, so by using this mathematics, so we can calculate the predicted states along with the prediction error covariance matrix. Okay, so by using, so QR is basically we are doing QR decomposition. Okay, by in this mathematics here. So by doing this mathematics, we can calculate the covariance matrix, prediction error covariance matrix, and further this SK dash, which is calculated through this equation 59. Further it is updated. Further it is Cholesky updated through equation 60, as you can see in equation number 60. So basically some weight factors have been weight factors are required for the calculation of prediction, and these are explained here in equation 61. Next is correction of states. So here again a new set of sigma points are calculated. Now here these predicted states which we have calculated from the prediction stage, they have been used for in order to calculate the correction step. Okay, and further this new set of sigma points which we are getting in the correction stage, they have been passed through this measurement update function. This is the measurement update function in order to get this thing. Okay, so that is YK actually. So that is basically a matrix which we are getting by passing the this new set of sigma points through this function. So basically here in this case, this function is basically incorporates the power system data, which we are considering as a line current as well as bus voltage, and we are getting from the PMUs, as well as we are considering, we are getting the data from SCADA unit also. Okay, like line flows, some power line flows we are also considering, like real power flows and reactive power flows. So basically, through this equation, the correction of the states have been performed, and finally, the estimated state or the corrected state has been calculated through this equation 69. So first of all, this is the predicted state which we have got from the prediction state, and next the Kalman filter gain has been calculated by using this mathematics. Okay, so, and this is the actual data or measurement which we are getting directly from the measurement device like PMU or SCADA. And this is actually the calculated measurement or the mean of the measurement which we are getting from this equation 64. So by using this equation, finally we can calculate the filtered or corrected estimated state. And so finally, after calculating the corrected state, the covariance matrix for the that is the filtering error covariance matrix, or we can also call it as a measurement error covariance matrix, can be calculated through this equation 70. And finally, again, it is being updated through this Cholesky updating factor by this equation 71. Okay. Now here, instead of using this direct algorithm, that means already I told that in this case, we are not using any separate bad data processing. So in that case, actually a new approach, that is Hubbard's M estimation methodology, that has been combined to correct the this thing that is been shown in equation 65. Okay, and that correction has been done through this equation 72. That means this RK dash, okay, that is actually shown here. So here, so basically this matrix, that matrix is actually being modified with the help of Hubbard's M estimation technique here. So basically in this algorithm, along with square root unscented Kalman filter, Hubbard's M estimation algorithm has been also combined. So basically Hubbard's M estimation algorithm is correcting this covariance, and this is the corrected covariance now. And this is done with this help of this matrix M. Okay, and this is found through this Hubbard's M estimation approach. Now, along with this algorithm, some other factor has also been considered here. Okay. Now, first is normalized innovation factor that is being calculated through this equation. Okay. And this has been incorporated along with the square root unscented Kalman filter, along with the Hubbard's M estimation technique. So in this with the addition of these two means with the addition of these multiple approaches in a single algorithm, it is actually it will be very much means it is actually giving much more easier for this algorithm to distinguish between the two anomaly conditions. So one is already, that is the bad data condition, and another condition is the sudden change in the load. Okay. So basically the asymmetry index is mathematically calculated through this equation 75 here. Okay, through 75 to 77. So these mathematics have been used to calculate this asymmetry index, and that is actually telling us that which measurements, what is the condition actually, that the anomaly is due to bad data, or maybe it is due to the sudden change in the load. So the flowchart of the proposed approach is shown here. Okay, so as you can see here, whatever we discussed here, that is being highlighted through this flow chart. Now here the simulation details, how the simulation have been performed, that has been discussed. So here how the power is being changing, means how the real power is changing, that has been showed for IEEE 118 bus test system. Okay. So this is in order to verify the algorithms. Here we have considered time sample as 70. Okay, so there are total 70 time samples considered, and each time sample is actually representing a duration of 20 minutes, so that we can cover full 24-hour cycle. Okay, so each of the time sample means there is a duration of 20 minutes. Now here also again the how the bad data and the sudden load change have been considered, that has been shown in this table. So here in case of two test systems have been discussed here for this in order to highlight the accuracy of the proposed algorithm. So one is both are larger test system like IEEE 118 bus system, and another one is NRPG 246 bus system. So basically first these are the bad data that has been considered. So basically V110 means this is the voltage data or voltage measurement at bus number 110. Similarly, this suggests that voltage or bad data at bus number 105. Okay. Similarly, this is actually suggesting the current. I is suggesting the current that is flowing between two different bus, that is flowing between bus number 110 to bus number 112. And so these are the data which have been considered as a bad data. Similarly, for NRPG 246 bus system also, these have been considered. Now for sudden load change condition, this scenario have been considered, that it has been considered that the load at bus number 12, that it is considered that it has been increased to 1.5 times of its actual load. Similarly, for bus number 118, the load has been reduced to 0. So this scenario have been considered. For NRPG 246 bus system also, this is considered where bus number 235 load, that is load at bus number 235, that has been increased to 1.5 times, and load at bus number 191 have been reduced to 0. So these are some of the results and discussions that have been given here. Okay. So basically here you can see in figure number 16, the J index for IEEE 118 bus test system is given here. Okay. So here among all the algorithms, different Kalman filter algorithms have been discussed here. Okay, in order to highlight the data handling during the presence of uh, bad data. Okay, so you can see here that these are the robust algorithm approach. So this is basically the proposed approach here, ARSQF, uh, and these are the robust approach, and other which is written here, that is unsended Kalman filter, CK, that means QHR Kalman filter, extended Kalman filter. These are non-robust approaches. That means they are not they are not been combined with some other bad data processing algorithms, or they are not a robust algorithms. Now here if we observe this result, then we can see the black one, that is actually handling the bad data, also it is handling the sudden load change scenario much more better comparatively to the other algorithms. Okay, that means we can apply this algorithm whenever there is a presence of bad data in the data set. Okay, so this black one is the proposed approach, and if you can also see during this time, suppose if we consider this instant, that is around 12th instant. So here you can see at 12th instant we have considered that there is a change in the anomaly, means there is a situation that is not a normal situation, there is a load change, there is a presence of bad data. So here you can see during this time instant, okay, time sample, the all the other algorithms are giving much more higher value, which is actually suggesting that these algorithms are not being able to handle the bad data or sudden load change scenario. So again we can see like here this here you can see that these algorithms are giving much more higher value. That means these algorithms are not being able to handle the presence of bad data. So from this figure we can justify the accuracy of the proposed algorithm. Similarly, other results have also been shown here, like if you can see in figure 17, where average absolute filtered state error for IEEE 118 bus test system has been shown. So here also you can see that during these conditions, like time sample 18 or time sample 12, see if you consider this time sample, so here you can see that these algorithms, that is actually your UKF, square root UKF or UKF, like these algorithms, they are actually giving much more error comparatively to the proposed approach, like which is shown in black color. So from this figure also we can justify the accuracy of the proposed adaptive robust square root unsended Kalman filter. Okay. Now in figure 18, Maximum absolute filtered state error for NRPG 246 bus system is also given here. Okay, so here you can see during this time sample, this robust approach is actually giving a very less amount of error comparatively to the other algorithms. Okay, so from all these figures, we can tell that the proposed ARSQ UCAP approach that is much more better comparison to the other algorithms. And also see, in this case we have not used some other bad data processing. Okay, so whatever the algorithm is giving, that means it can handle the bad data without incorporation of any bad data detector algorithms. Okay, so that is actually the advantage of using a robust algorithm during the presence of bad data. Some statistical parameters results have also been shown here for all the methods here. Now you can see here the proposed approach is giving less amount of statistical errors for in comparison to the other approaches. So this table is for IEEE 118 bus test system, and table 8 that is being for NRPG 246 bus system. Now from all both the tables we can see that the proposed approach that is actually giving the less amount of estimation error, that is the statistical parameters error, which actually suggests that this algorithm is much more better in handling the bad data. Okay, whenever the data have been contaminated with some uh, uh, very much huge amount of noise, that is different from the Gaussian noise. Means the noise is not a Gaussian noise, the noise is a non-Gaussian noise. Okay, now the next topic is that here how to handle the data. Okay, so how to handle the data if there is a cyber attack. Okay, and in this case also we can apply machine learning algorithms in order to handle the data against the cyber attack. So basically first we have to understand what is cyber attack in power system here. Okay, so basically, cyber attack means here the attackers, means whoever is doing the attack, they actually try to disrupt the electricity. Like if you see some present scenario, if you recall that around in the year of 2020, there was a attack in the electricity in Mumbai, and that is due to the that is actually due to cyber attack. Okay, so that is one type of cyber attack. So basically, cyber attack means here the attackers is actually trying to disrupt the electricity, like by incorporating by introducing some false information, or it could be either like some denial of service, like it could be for particular time instant you are not getting the actual data. So that is also one type of cyber attack. So here basically I will discuss a particular type of cyber attack, that is a false data injection attack. So false data injection attack is a one type of cyber attack. Now what is actually it is doing here? It is actually changing the stored or transmitted data. So whatever the data is actually already we discussed that PMOs are getting the data. PMOs are actually transmitting the data to the PTC. Now in this case, suppose the PMO is transmitting the data to the PTC. Now in between this channel, the attacker what it will do, it will manipulate the data. Now that is different from the bad data which we have discussed in the earlier discussion. Bad data is something which is due to manufacturing defect or faulty PMs. But false data injection, that is a means that is due to the attackers. Means it is designed in a such a way. It is designed in a such a intelligent manner that normal algorithms may not be able to detect the attack. So that if there is an attack, then there will be a disruption of the electricity. Okay, so basically in false data injection attack, what is actually happening in between the transmission of the data from the PMOs to the PTC, the attacker will change the data or manipulate the data. Okay, and the thing is that actually whatever the data we will get at the control center, in that case we will get that it is like a normal data, but nothing is happened. But in between that, the attacker has actually changed the data, and he or she has done the
Okay,
change
Subraj,
in such.
Kundu, sorry to interrupt
Yes,
you
sir.
actually.
Yes, sir.
Sir, actually, you are telling a cyber attack, whether the
Yeah, yes, sir.
particular server will be completely attacked or what actually, that
Sir,
electricity
yeah,
PV
yeah.
server.
Actually, yeah. in that case, sir, actually, suppose we are transmitting the data from that. Here you can see here in the next slide, I have drawn this figure. Okay, means this
Okay,
is
sir.
the okay. So yeah, I can explain from this figure. Okay, so
Thank you.
basically, yeah. So see here. So how the data has been manipulated. Now that can be explained through this block diagram here. Okay. So here, so this is basically our PMO, that is phasor measurement unit, which is actually giving us the information. Now, here in between this process, see there is a attacker. So B is the attacker. Now, what is actually it will doing here? It is incorporating C from PMU to PDC. The data will be transmitted. Okay. Now, in between this process, the attacker will add some attack vector. Means in order to change the value, what is the actual value. So in that case, uh, the attacker has incorporated a false data injection attack in between this path. So in between this path from PMU to the PTC, the attacker has injected this attack. Now this attack, how this attack has been injected, that the mathematics I will tell you in the next slide. But so this is basically how the attacker is doing. Now how you can see here. So basically you can take an example here. So see, this is the PMU data before attack, before false data injection attack. So here you can see this is the information. This is actually the actual information. So here you can see that is 2453 plus 2444J. So that is basically one voltage information. That is the actual information. Now after the attack, the information you can see, this is the actual information. Means this is the information after the false data injection attack. So here you can see that value has been changed. It is completely different. If you see the second one, here it is written 2954 plus 2780J. But here you can see this data is totally different. Similarly, the third data, that is also totally different. Now, this is actually the data after the attack. Now, if this data is being sent, so attacker has changed the data. Now, this data has been sent to the phasor data concentrator. Now, this phasor data concentrator will transmit the data to the control center. Now, whenever this control center will uh, do the further analysis in power system using this data, so that will give you a totally wrong result. Like if we perform state estimation or other operation in power system, in that case it will give you a total wrong result. And in that case, by in that process, actually the electricity will be disrupted. So in that case, by causing this false data injection attack, by incorporating this false data injection attack in the system, and that is actually the attacker is incorporating here in between the communication path between the PMU and the PDC as shown in the diagram. Okay. So after the data, that is the PMU data, after the attack, if it is being sent to the PTC, so after the PTC, that will be sent to the control center. Now, whenever the engineers who are present in the control center, they will do the further analysis in the control center. In that case, the result will be totally different. So what will actually happen, that will totally give you a totally wrong information, and in that case the electricity will be totally disrupted. So in that way, the cyber attack may cause disruption. Okay. Now here, in order to detect the false data injection attack, first a mathematical approach has been considered here. So basically, this detection method, first it is monitoring the changes in the PMU measurements between the present day, time of the day instant and one step previous time instant of the day before. Okay, that means present day, we are comparing the data that we are getting from the PMU of the present day as well as the previous day. Okay. Now, after that, the variation of these which you are calculating, that has been compared to the variation of the forecasting measurements. The forecasting measurements can be done through any kind of forecasting algorithms. So by comparing that, we can doing this variation. Okay. Now, after that, a mathematical approach, that is Manhattan distance, have been implemented to calculate the distance, so that if there is a attack or not. Okay. So basically here, this approach has been tested on two systems, as you can see here, IEEE 14 bus test system and IEEE 118 bus test system. So here, now you can see this is the mathematical model. So basically, this one is the attack vector, and this attack vector will be generated by the attacker. Okay, and it will be generated in an intelligent manner. So that normal detection algorithm, which we have discussed in the earlier slides, in that case, uh, the bad data detection algorithm can detect the bad data. But if a false data has been incorporated by introducing this attack vector, in that case it will bypass the bad data detector. Okay, and how the attacker is manipulating the data, here you can see this is the actual data which we are getting, the means which is actual the data from the PMU, and after that this is being added with the attack vector. So finally, whatever the attack vector means, whatever the data the PDC is getting from the PMU, that is actually the manipulated data by some attackers. Okay, so this is basically the manipulated data after the attack has been occurred. So here also see, the thing is that if we see focus on this mathematics, that is 82. So that if we calculate the residual by using this mathematics, now you can see it is giving actually the same residual in case of normal scenario. Now the conventional bad data detection algorithm, which we have discussed in the earlier slides, they are based on checking the residual. So in that case, the normal bad data detection algorithm, they will not be able to detect the cyber attack or false data injection attack. So here, for that a methodology has been developed here. So first, this alpha var has been calculated by equation 83. Next, the variation of the forecasted measurements of the present day as well as the previous day has been considered. Okay. Similarly, this one is the present day measurement data, and this one is the previous day measurement data. So this comparison has also been done, and it is calculated through this mathematics. Okay. Next, the deviation of these two different measurement variation have been computed, and finally this will be passed through a Manhattan distance by using this equation 86. So finally here we are calculating this Manhattan distance of del, which is we are representing through P dist. Now if your P dist is higher than a particular threshold, then we are telling that this particular time instant the cyber attack has occurred. Okay, and if it is not, that means there is a normal scenario. So this is basically the flowchart of the proposed scheme. Okay, now the simulation details have been shown here. So basically the simulation details is almost similar whatever we have discussed in the earlier slides. Okay, this is a single line diagram of IEEE 14 bus system, and these are showing that in this particular substations or buses, the PMUs are placed. Okay. Now, some performance evaluation indices have been considered here, like false positive rate, false negative rate, and true positive rate or detection rate. Okay. Now, table 9 is actually telling what are the states that had been targeted by the attackers. Okay. Like for IEEE 14 bus system, the objective of attacker is to manipulate the power system state at bus number 9, bus number 12, and bus number 30. Okay. Similarly, for IEEE 118 bus system, these are the states considered. So as you can see this figure, you can see during this time instant, you can see that the p-dist value is becoming much more higher in comparison to the other scenario. That means in this time sample, there is a presence of false data injection attack. Where in case of normal condition, there is, you can see here, the value lies much more lower. Okay. Similarly, from this figure, we can see what are the measurement data that has been attacked by the attackers. Means these are the data that has been targeted by the attackers. Means these data have been manipulated by the attackers. Okay. So this is basically false positive rate has been shown with the change in the detection threshold. So as you can see, whenever the detection threshold is very less, the false positive rate is little bit higher than 0.25. But as we increase the detection threshold, the false positive rate becomes totally zero. Okay. Similarly, the variation of true positive rate has also been shown here with the change in the attack magnitudes. So basically, we can see that whenever the attack magnitude is 0.01, the true positive rate is little less than 0.9. But as we increase the attack magnitude, the detection rate has become 1. And throughout the attack magnitude, the detection rate is throughout 1. Okay, that means it can successfully detect all the attacks that has been occurred in the system. Okay. Similarly, for IEEE 118 bus test system, similar type of results have been shown here. So from this, you can see that these are the time samples where the data has been attacked by the attackers. Okay. So here, these are the measurement data which are being attacked by the attackers. Okay. Next is detection false positive rate, and it has been compared with the detection threshold. So here also you can see with the increase in detection threshold, the false positive rate becomes eventually 0. Okay. This is the true positive rate, which has been shown with the change in the attack magnitude. So you can see that it is throughout 1. That means the algorithm is successfully can detect the attack. Okay, for the any type of attack magnitude. Now, apart from this previous algorithm, some machine learning algorithms can also be implemented to detect this problem, that is to detect the false data injection attack. Okay. So first one is logistic regression. Okay. So basically here the mathematics for logistic regression is given here. Okay. So basically it is based on a sigmoid function, as you can see in equation 92. Okay, where Z is basically represents the linear combination of input features and the coefficients, and it is given in equation 93. Okay, where X are the input features and beta naught, beta 1, beta 2 are the coefficients that has to be learned. Similarly, some other machine learning algorithms is decision tree. Okay, so basically here the objective is to maximize the information gain or minimizing the impurity. So the mathematics is shown here, as you can see here. This is basically the entropy. Okay, so it is actually telling us the amount of disorder or uncertainty in a particular set of data points. Okay, and pi, that is actually telling the probability of each possible outcome occurring. Okay, now this information gain that is being calculated through this equation 95. Okay, and if this is actually telling the information gain, so if this is the objective is to maximize this information. Okay, or other than that, Gini impurity can also be calculated here. Okay, as you can see here, it is shown in equation 96. So another classifier algorithm is random forest classifier algorithm. Okay, so here basically it consists of a combination of tree classifiers. Okay, where each tree classifier generating using a random vector. Okay, sampled individually from the input vector, and which in actually combination makes the random forest classifier. Okay, so basically in random forest classification, each tree calculates a unit vote for the most popular class to classify that input vector belongs to which class. Okay, the Gini index have been also be calculated here, as you can see here in equation 97. So basically here this mathematics that is actually representing the probability that the selected cat applies to a particular class Ci. Okay, now, apart from the other machine learning algorithms, another algorithm is also discussed here, that is extra tree classifier. So basically here, the steps have been shown here. So basically the first from the original data, a random selection of the input has been done. Okay. After the selection of the random input, some random vector have been utilized to build multiple decisions. And finally, the combination of the decision trees. Okay. So by this way, we can use the extra T classifier for detecting the false data injection attack. So basically, this is one of the ensemble learning algorithms. Okay. Now, some results by using machine learning algorithms have also been shown here for this particular problem, that is detection of false data injection attacks. Okay, so here you can see here some supervised machine learning algorithm techniques have been discussed here. So as you can see here, the extra tree classifier, that is this one, that is giving the uh, much more accuracy, that is 0.98. So basically this is the receiver operating characteristics curves, which is plotted between true positive rate and false positive rate. Okay, so here you can see the other algorithms like linear logistic regressions, they are not showing very good amount of results. But if you see other techniques like extra T classifiers or decision tree, they are giving random forest is also giving accuracy of 97%. Okay, so this is the ROC curve. Now here the confusion matrix have been shown, okay, for the different algorithms. So this is for your extra T classifier. Now you can see that in case of extra T classifiers, the confusion matrix, if you see, in this case, that is actually the 719. This is actually the cases where actually the attack has been occurred, okay. And predicted level is also actually suggesting that correctly detecting the this number of instance where the attack has been actually attacked, okay. So that is better comparatively to the other approaches, like here you can see it is 679, okay, here it is 712, okay. Now performance metrics comparison for different machine learning algorithms have also been shown here, okay. So here from this you can see that extra T classifier is giving the better result compared to the other machine learning classifiers, okay. So here the accuracy of the proposed extra T classifier, okay, along with some other methods which have been published in different articles, that has been compared, and from there it has been shown that this extra T classifier is actually giving much more better accuracy compared to the other machine learning algorithms, okay. So next is conclusions. So basically, uh, here in this discussions, basically first two novel non-iterative optimal state estimation approaches, that is NSSE and NDSE, have been discussed to validate the measurement data in power systems. And it is observed that both the approaches are non-iterative in nature. So we can get the optimal solution directly instead of the suboptimal solution. Further, for prediction purpose, BT smoothing method approach have been considered instead of other two approaches like Holt's two parameter and Brown's double exponential. And finally, instead of deleting the bad data from the data set, it has been corrected. It has been initially detected, identified, and finally it has been corrected. Okay, so that the algorithms can handle the bad data better. Okay. Finally, another algorithm has also been discussed for handling the bad data in case of power systems. And from the test results, we can see that by using this adaptive robust square root unscented Kalman filter, we can handle the bad data without incorporation of any extra bad data detection algorithms. Okay. Next, that detection approach for false data injection attack, and what is false data injection attack, and how to handle this malicious data against the cyber attack or this false data injection attack, that has been discussed. So from the detection results, we can see that the algorithm can successfully detect the false data injection attack. And finally, some application of various machine learning algorithms like logistic regression, decision tree, random forest, and extra tree classifier have been further applied to detect that false data injection attack has been occurred or not. Okay, so these are the references for these discussions. So thank you. So that is all from my side. Now, if you have any query, I am eager to answer that.
Sir, thank you for your session, Mr. Jyoti Kundu.
Yeah, thank you, sir. Yeah,
Yes, sir. Two, three questions I am having in my mind.
yeah, yes, sir. Ask me,
So
sir.
many algorithms you have shown in the model.
Yeah, yes,
So
yeah, yes, sir.
any of our grid, in government of
Yeah,
India, government of any state, they
yeah,
have
yeah.
implemented this. Any idea on that?
Yeah, sir. Actually, see,
Cyber attack.
yeah. See,
Long,
actually,
long,
in if you are talking about practical power system, then the conventional algorithm is already been implemented, and that is through a software. So, if we visit any of the control center, then that algorithm, that means that state estimation algorithm, is already been implemented. Now, these are the algorithms where we can further improve the further we can improve the handling of data. So basically, if we see any of the power systems and in any control centers, the conventional algorithms like which I discussed earlier, like extended Kalman filter based or weighted least square based
very
static
important.
state estimation.
Yes, you have shown that. Yes.
Yeah, which I have shown in the first slide. Actually, there. See.
I understood. Mathematically, of
Yeah,
course,
yeah,
so many
yeah.
things we can
So,
see that.
so
Simulated
basically
model.
that type of, yeah, so basically that type of algorithm is already in there in the practice, but this is actually a step further ahead so that we can further improve the power system security.
Okay, thank you, Mr.
Okay, thank you, sir. Yes.
Any other queries? Please do ask. Please do ask. We've still got around 2 to 3 minutes of time. Please.
Sir, absolutely. You had shown it very beautifully. You had shown so many algorithms in it.
Yeah,
Thank
thank
you
you,
for
sir.
a wonderful session.
Okay,
I
thank you,
just
sir.
wanted to ask you is that
Yeah, yes, sir.
uh, basically for any of the model, the random forest and
Yeah, yes, sir.
distribution that you have shown,
Yeah, yeah,
uh,
yes, sir.
will it be applicable to all the means all the perspective for machine learning algorithms that we
Yeah,
use for
yeah, yeah, yes, sir. Actually, all the machine learning algorithms can also be applied. Along with that, some deep learning algorithms like ensemble deep learning, which we can also implement in order to detect the false data injection attack.
okay, sir. Thank you.
Okay, thank you, sir.
Okay, so thank you so very much, Dr. Subhajyoti Kundu,
Okay, thank you, sir.
for
For your,
for such a wonderful talk that you have given,
yeah,
especially from the
thank
side
you
of
very much, sir.
sector. And thanks to AICT Atal for sponsoring this whole
Yeah,
FDP, and to such great and generous speakers of ours, as well as to some of the finest, faculty members, those who have joined us in this FDP. Thank you, sir. Thank you so very much. Now we'll start up.
okay, thank you, sir. Okay.
Thank you, sir. Thanks. So we'll now start up with our valedictory session. And in this valedictory session, Jitendra Kanungo sir will introduce our respected registrar sir, will be coming up or joining up very soon. I hope he might have joined also. Just a second. No, he'll be joining very soon. So, Kanungo sir, kindly do take care. By the way, immediately after this session, exactly sharp at 7, the test will start. And there are two provisions of giving the test. You can give it via the Google link that will be shared with you, as well as it is available in our portal. If you have really known me and trusted me, I'll tell you, you can go by the Google link only. And some of you, those who are willing to, they can go by the test in the portal. But in the portal, it will start automatically at 7, right? Sharp at 7, it will start. So please be there. And whichever part you want to give the test, you can give it. But remember, wherever the time stamping will be first, will be taking up that. And most probably the time stamping, wherever you will be giving first or submitting first, that will be picking up. And if you are having 1 mark higher in one module and 1 mark lower, preferably you'll be picking up the lower one because you might have seen the questions from there and then you have shifted back to another domain, like from the portal to the Google Forms or from Google Forms to the portal. So we'll pick up the smaller one. So preferably pick up any one and you can go with that.
So Google Form also will be releasing by 7, sir.
Yes, sir. Exactly at 7.
Thank you.
Exactly at
Google
7.
Form, we are very comfortable, sir.
Yes, sir.
Thank you
Do
very
it in that. Do it in that, sir. Ganapati, sir. Do it in that, sir.
much.
Do it in that, sir. And Google Form, we will be doing manually, and the portal one will automatically start at 1900 hours. Right. So please do cooperate with us. Sir will be joining soon. Give me some few seconds of time. Let me give a call to sir.
So I will go back Google Form only because in the website there are many problems and at the end it gives an error
Yes,
message
ma'am.
also.
Yes, ma'am. Let me tell you, I'll take another 2 to 3 minutes of time. I have traversed in this age itself. I have gone through all the paths. For almost 4 years, I had been attending the AICT Atal FDP. I have been the expert talk deliver. I mean, I have delivered talks also. Then I have become the coordinator here. I have seen all the steps out here one by one. And I had been through a seasoned campaigner through all these paths. I have taken almost 4 years of time to travel through each and every nook and corner of this. Sometimes what happens immediately when around 285 people, and that too simultaneously, remember, around 17 FDPs are there right now, right here. So when they all will be there on the same website, na, it will have some issues. It may have some.
Exactly. Exactly,
Exactly,
sir.
sir.
Sir,
We are
it's
vector
always
tracking.
there. Issues are
We are vector
always there
tracking.
on website.
Yeah, but to satisfy my always condition is to satisfy all my critics first. There are a lot of critics also in the world. Those will always ask, why not there? Why here? So I give all the opportunities, all the options to each and every individual. And I love when people criticize and put up that why this thing is like this. That gives me an impetus to even put forward much more things for the people around me, those who have always loved and supported me. So please give me some time so that I can give a call to sir.
Sir, when we get exam in using Google Meet, sorry,
All at the same time, sir. 1900 hours. 1900 hours.
1900 hours. So
Yes.
when we got our certificate in our Atal FDP portal,
Atal FDP portal. Just a second, sir. Give me some time, sir. It will hardly take max 1 week or preferably by Monday morning or Tuesday morning.
okay, we will get on Atal FDP portal na directly.
Yes, on your portal it will be there. You just have to download it. I'll tell you everything.
Okay.
Sir will be joining in the next 2 to 3 minutes. Jitendra sir will be introducing sir. Acha, let me tell you one thing. These are all experiences. These are all experiences. I have been experiencing a lot of things. From the age of 20, I had been experiencing things from my BTech final year itself. Okay, let me tell you, if you start downloading your certificate from your mobile phones, it will not get downloaded. Remember, you have to download it from your systems only. Sometimes it gets, but there are a lot of hindrances that comes up. So please don't complain if you're doing it from your handheld devices. Do it from your system, from your computers, from your laptops. You're going to get it very easily. But if you're doing it from your mobile phones, it will not get downloaded easily. So within 2 to 3 days, please be there. Click on the certificate section. Choose JP University of Engineering and Technology. You can see my mail ID there. Just below that on the red part of the tab, click it, download, and the certificate will be downloaded. Many of you know the process. Don't do it from your phones. Do it from the system itself. All right? And please give the test. I know many of you are having your friends also, those who are attending with you out here. Please advise them to somehow give the test. Please give the test. Please. If you don't give the test, we cannot help you out at any point of time. Yeah, ma'am, you can give the quiz from your phone also anywhere. I hope, I think I might have written it on the Google Meet also that.
In the chat box only, we'll be listening the question, sir.
Sir, please. Sir?
in the chat box only you will be giving that Google question,
Yeah,
right?
yeah, yeah. Yes, yes, yes.
Not in
There also
WhatsApp, not WhatsApp.
in
Oh, okay.
yes, sir. In our WhatsApp also, as well as in the Google Meet also.
Thank you.
Need not worry about that. In all the
Okay.
places, it will be given to you. Just immediately after this valedictory, sir will be joining very soon.
Sir, it's already 6:37.
I know,
So,
I know, I know, I know, I know. We are doing it. We are doing it. Yeah, yeah, Rakhi ma'am, we are doing it.
Excuse me, sir.
Yeah, ma'am.
The quiz will be open for how many hours? Like from 7, what is
It
the
will be
time frame?
preferably for 30 to 35 minutes.
Okay,
Every
so it
15
will be
questions.
okay. 30 to 35 minutes is it is
Yeah,
open, right?
yeah,
Okay.
yeah.
Thank you.
Okay. So you can share your thoughts with us immediately after Registrar Saab will deliver his talk. Just a second. Oh, Registrar Saab has already joined. Respected Registrar Sir, Dr. Sanjay Mishra Sir. Sir, Kanungo Sir. Dr. Kanungo, are you there? Dr. Kanungo, are you there?
He left, sir.
Okay, 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 let it be. We have, okay, we are out here with our respected registrar, sir. He is Dr. Sanjay Mishra, sir. He is the registrar of JP University of Engineering and Technology. And he has been a wonderful person tackling all the administrative responsibilities of the JP group. So, sir will be now delivering his viewpoints on this Atal FDP for the next few minutes. After that, we'll be listening to your thoughts and then we'll go for the test. Sir, are you there?
Yes,
Registrar, sir, are you there? Sir, please.
may I?
Yes, sir. You're audible. You're perfectly audible, sir.
So thank you, Dr. Banerjee, for inviting me for this wonderful FDP and delivering my valedictory speech. It's both an honor and privilege for me to address this wonderful gathering. I believe in this past sessions, the journey together must have been on the evolving landscape of AI with a particular focus on interpretation of the natural languages. To me, language is excuse me. To me, language is a representation of thoughts, but it is definitely more than words and grammar. There are lots of emotions. There are lots of subtleties in the language, and that is where I believe the challenge is how AI will interpret that accurately. AI will definitely interpret that, but how accurate it can be. It really needs lots of understanding of the different diverse cultures, different professions and stuff. Uh, I really wish that this forum must have deliberated very deeply on these aspects. As far as the future perspectives are concerned, how I see this particular FDP, like it must have taken a shape of some decision towards the evaluation of new technologies, the multimodal representation of the different the technologies those are prevalent in the market, in the arena, how machines they learn from machines, how machines they learn from human beings, and at the end of the day they can come closer to the interpretation of the actual human thoughts. Let me relive my past. When I was young, I used to see the movies like Terminator and all that, and whatever I used to study was very different from that, and we could hardly believe that. But today, it's a reality. We are very close to that, right? To me, AI not only talks about the interpretation and subtlety of the languages, but it also brings in, like one thing called very rapid growth on one side. On the other side, it also calls for a responsible behavior, um, which in a way, like, I should talk about ethics out here. So all the dignity, all the faculty members, respected faculty members, all the dignified speakers must have emphasized on this aspect as well, that how to be responsible and how to be ethical, so that whatever we do with the help of AI remains fair and trustworthy. Another aspect, if we have done all this, then where all AI can be applied in this natural language processing, where it can be applied. And believe me, first thing that comes to me is education. Education will make people once the students are used to using this AI ethically, it will add new dimensions like utilization of AI into healthcare, governance, research, industry, and where not. There are certain challenges. Yes, we have been reading that AI is eating jobs, but AI is also creating jobs. So threats are there, but potential is boundaryless. You can go anywhere. However, the 6 days grind is towards the end. We must have discussed and concluded on lots of opportunities and challenges. Yet, there are certain privacy concerns, the biases, which are yet to be answered. And this forum must have together try to answer those. So I will like to conclude my speech with that we should go away from this this FDP with a commitment to ourselves that we will innovate, we will be responsible, and more than that, we will be human centered. I extend my heartfelt gratitude to the organizers, speakers, participants, and all those who have made this program successful and thought provoking. Thank you very much.
Thank you, sir. Thank you so very much. Thanks. Now it's the time for you to share your viewpoints. If at all you would like to suggest something, you'd like to convey your messages to us, you can say it to us. This is the forum where you can say something to us. We still have around 16, 17 minutes of time. Sir is also there. You can share your views. For the last almost 6 days, we all are together. You can share your views. Ganapati sir, something from your side, sir.
Definitely, sir. Thank you very much for the past 6 days. Particularly, I want to thank Dr. Partha Sharadi, sir. Actually. So fantastic, actually, how you are doing the course completely all the days, anchoring. Very, very, very nice, actually. Really, we all enjoyed that all the days, actually, particularly that cyber security, which your people covered. Highly useful. Actually, I am from industry. I was there from NIC for the past 38 years service.
National Informatics Center.
NIC, NICnet.
Yeah.
Mighty. After retirement, I joined as a professor. So I'm just interacting with the students.
Great.
So definitely it will be very much helpful, sir. Actually, I'm having a practical exposure of, like your registrar told, education is the first thing. We have to implement AI, sir. And ethical other things. Sir is pakka. He is 100% right for research, sir is. Very much thank you, JP University of Engineering and Technology, Guna.
Thank you.
Thank you. Thank you very much. Thank you very much.
Thanks. 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 Any other person, please, from JP itself or from, we are having around 105 institutions pan-India wise who have registered for this course from around 19 states and near about 37 districts to 40 districts and 285 people. So you can say and share your views if you feel like.
Okay, pleasant evening, sir. Actually,
Oh, hi, good evening.
you done very good job, sir. Actually, really, you are empowering the education as well as enhancing the knowledge to the faculty members, because of we faculty members are the tomorrow leaders. We are creating tomorrow leaders for the
True.
students community.
True, sir.
So if you are empowering education through this online mode, I am very happy to attended. I was attended more online activities. Out of that, you are conducting excellent actually. I want to say that word actually.
Thanks.
So
We all
all experts, their knowledge sharing it was very excellent actually. I want to happy to hear actually. Really,
I
you did
I,
a
I
very good job. I
I
want to
strongly
say
thank you
multi
so
thanks
much.
to you and your management because you done
I strongly
uh,
agree that during
really.
some of the talks there were a little bit of noise at the background, sir. That really
Regarding
happens because we do have speakers from various different dimensions, from various different age groups, from various different experiences. So sometimes some of the lacunas are there, and trust me, over the years, AICT has many a times rescheduled some of the speakers because there was no connection, no something like that. It has happened, sir, but we somehow manage the things properly on time. Majority of the occasions, we haven't wasted any of your time. We have filled up the gaps, filled up the voids wherever it was there with some sort of informative information regarding the subject matter. Any other person who would like to share something? We still have some good amount of time. Yeah, please. Karan sir. Karan Mahajan ji.
Good evening, sir.
Yeah, good evening. Good
Uh,
evening, sir.
First of all, I would like to thank you and your university and Atal for these wonderful sessions. And all these sessions were very nice and very well captured by all the speakers. Personally, I would like to recommend the last session which was delivered by you yesterday night. It was so nice that you have shared.
Thanks a lot. Thank you.
Yeah, yeah, because that type of information was never been given to us in
I,
my 18 years of career. Thanks, sir. Thanks for your support. Thank you very much.
thank you. It was like I knew that I cannot be the resource person. So still, since there was a small time gap of 25 minutes, I thought of
Yeah.
sharing some of the things which you might not have heard before.
Yes.
Majority of you. So
Yes.
I thought of sharing with you.
Thank you, sir. Thank you
A
very much.
lot of information is available from the side of our government, but many of us we don't even know. We always know Kaggle, but we don't know data.gov.in. It is also there with all the meteorological, all the medical data that is available. Okay, whatever. Any other person would like to share something with us? Rakesh Sharma, ma'am.
A very good evening, sir.
Kapil sir. Yeah.
Yeah, actually, it is a very informative FDP that you have arranged. Thank you, entire team of JUET University, and especially to you, sir. Complete 6 days you were sitting at your office conducting this session, right? And seeing that I managing all the resources, it is very hectic when this complete, and that is to be completed in the time.
Kapil sir, this is a forum where I can say something not informal, but something formally informal.
Yes, yes,
Let
yes.
me tell you, I do work. Do you know why I sit back for long hours?
Hmm.
Because literally, I don't have anybody back at home. I only do have my aging parents. Right. So I do have ample amount of time of getting funding, talking with people, interacting with a lot of people, conducting conferences, FDPs, getting fundings from various agencies. I invest my time a lot out here because I don't have any other thing to do, in fact, in my
Yeah,
life.
yeah.
So I sit back for long, long hours, and let me tell you, I'm wholeheartedly thankful that even though we are not NITs, ITs, or triple ITs, but you have overshoot the total numbers. I mean, Isha ma'am will be the next person. Her FDP will be starting next week. I mean, from Monday onwards. She was having an interaction with me informally. So I'll tell you that you people, despite of we not being the ITs and NITs, you have touched the above average mark. The average being at around 250 plus, we reached around 300, out of which we selected around 285. Thanks a lot from the core of my heart. You again made us successful by being with us, and I'll always be thankful for you. I mean,
Yeah, and thank you very much. You had covered every aspect of AI, the subsets of AI, NLP, deep learning, every aspect in it, and most probably the actual implementation of all the things. That was a very good part of this FDP. That is a takeaway from for all of us from this FDP. Thank you, sir.
Thank you so much. Any other person who would like to share something else?
Very good evening, everyone. So
Isha,
I
ma'am.
would like to thank, yes, I would like to thank the university for organizing this, especially you, Banerjee sir, and also the both the organizers. And
Understood.
I still remember from the day one, you are just helping us in the every aspects. And every speaker was very good. The activity was a great success, and even you gave a very good, the different sources for us so that we can explore more. Thank you so much, sir.
Any other person who would like to say to all the people, those who are saying good words as well as some suggestions from the chat boxes. I appreciate, I acknowledge all your suggestions. Thank you so much. Thank you. Thanks a lot, Anima ma'am, Prashant saab, Kavita ma'am, Jan saab, madam, Seema Patidar ma'am, Hemlata ma'am. Thank you so very much, Rano ma'am, Aisha Siddiqui madam, Vandana Patel madam. Thank you. Thanks a lot. Thank you. Thanks to all of you. Thank you. So now we'll take permission from our registrar, sir. Sir, thank you so very much for being with us. Now is the time for the quiz and test for our participants. So thank you, sir, and thank you, all of you. Thanks to all of you, in fact. And my and Kanmu's number is there with you. Vijay sir, thank you so very much.
Thank you
Anji
so
ji,
much, sir.
thank
I want to acknowledge to your university, JP University,
thank you, thank
especially
you.
you, sir, for coordinating. I am from Mumbai, Father
Oh,
Agnel College. I felt
okay,
very
great.
happy with through all these sessions and thank you for your support, sir.
मैं
Thank you.
मैं भी बॉम्बे में ही था ऑलमोस्ट फॉर 2 years एट नवी मुंबई सीबीडी
Yes, sir.
बेलापुर
Sir. Okay.
सीबीडी
Okay,
बेलापुर में ही पोस्टेड था वहां से फिर मध्य प्रदेश आया
okay, sir.
वंडरफुल प्लेस एट बॉम्बे थैंक यू
Okay. Thank you, sir. Thank you. Bye.
थैंक यू
Thank you, Banerjee sir, for giving an opportunity.
थैंक यू थैंक यू तो
Thank you, Banerjee sir. Thank you.
राखी मैम या प्लीज मैम
Yeah. Thank you, sir. I am from Gurugram, Haryana. It was really a very informative and nice session, especially the implementation part, NLP, LLM, everything was good, sir. Thank you, sir. Partho, sir. Thank you.
थैंक यू
Thank you, sir. I am from.
या वीरेंद्र साहब आई नो यू प्लीज सर
Yeah,
कैसे
sir.
हो रे
बढ़िया sir.
सब सही
Yes,
सब अच्छा
सब बढ़िया sir, बढ़िया.
बस बस सब बढ़िया रहना चाहिए भाई भगवान का आशीर्वाद बने रहना
बिल्कुल,
चाहिए
बिल्कुल sir.
Sir,
आप
good.
लोगों का आशीर्वाद है.
या अनुष्मा मैम
Yeah, sir. Good evening. Good evening, and very thankful for all the speakers of the sessions and also the organizers. They have organized such a wonderful sessions, and although the speakers were very good, they have narrated like a story, and where we could get the information very easily. When we read the textbook, it was very hard not to crack. But when you told that NLP and all and its applications, it was really amazing and wonderful, which has strengthened our skills in understanding it and putting on to the applications. So I equally congratulate the coordinators and also thankful for the speakers for deliberating such a wonderful content so smoothly and in an understandable way. Thank you so much, sir. Thank you so much.
okay ma'am thank you okay so now you have got around 4 minutes of time so you can prepare your desktops you can prepare your handheld devices for the quiz it will start sharp at 7 and my contact details are there with you. Kanungo sir's contact details are there with you. You can contact us at any time. But sometimes I ask a question to people whenever you come for any sort of research collaborations or funding collaborations from outside and there. But I sometimes ask a question, what is in it for me? मेरे लिए क्या है उसमें? So it should be a win-win condition for both of us. If any one of you is interested, तो मैं टाइम इन्वेस्ट करता हूँ रहें jvt.ac.in के साइट को विजिट करें my number is with you my email id is with you I keep on posting my things on my social media on Instagram handles on LinkedIn on all these various places. I keep on posting things. Right. Thank you. So I'm taking a small break of 2 minutes.
देखा पीछे लगे
My one request, please give the test properly and get 80% of marks. Please do get, huh? Please do get. Please, आपको आपको 80% आए, मैं चाहता हूँ दिल से आपको आ जाए. Please give the test properly. Please. Now it has started on the portal also, and the link has been shared. Just a second. The link has been shared. Please, your time has started. Please start up.
Sir, link is on Atal portal or sending here? Hello, sir. Link is on Atal portal.
No, no, link is on WhatsApp. On WhatsApp group.
Okay, okay. Thank you. Thank you.
It is there. Please start. Please. I have pasted it on the Google Meet also.
Sir, if taste and everything is done, can we leave the meeting?
No, after you are done with your test, you have to go to the Atal portal and give the feedback there.
Okay.
There is a section of feedback in the Atal portal only. Please go there and give the feedback also. Please, all of you. Immediately after giving the test, go to the Atal portal and give your feedback there.
Is no submit feedback option is
No, no, in Atal portal it is there, ma'am. It is live. It is live. It is there, ma'am.
so, but I filled all this can't, but the submit feedback submit is inactive. Submit button is inactive there.
Where? Where? On Atal portal?
Yes, sir.
No, no, impossible, ma'am. That is been given by the side of AICT. That feedback is from their side. It is. I do have a other login also, ma'am. I do have a
But
separate
I'm
login.
just
Just a moment.
I fill all the entries and when I click the submit feedback, then that is not
9-7. In the afternoon
active.
only, there are two candidates. Those who were saying that we are filling it up.
Sir,
Then
Atal
the fit.
portal is showing a bad gateway error. It is not working right now.
Acha, maybe some issues are coming up because everyone is putting up. Actually, other
Yeah.
MDPs are also there, na?
So can we fill that in tonight?
Yes, yes, definitely, definitely. At any point of time, I mean, after 12 also in the morning also you can do it. But the moment you will do it, only after that you will get the certificate. Because even if I generate the certificate from my end, you will not be able to see it if you don't fill up the feedback. Just a second, let me also check it at my end. What my portal is saying, let me see it. I'll let you know. Just be there. Just be there. Just be there. August 30. Yeah. It's open. Feedback is open. Details about the workshop attended by the participant. It's
So
there.
actually it is open, but the submit feedback button is not active.
Sir, will you please share the Atal FDP link here in a meeting or in a WhatsApp group? I'm unable to open it. I
Atal
got it.
FDP link you don't have?
Sir, I
Yeah,
have
yeah, ma'am.
done with the test and
Okay.
submitted the
Feedback also.
feedback also. Yes, sir.
Bas, it's done. It's done.
Can I leave, sir?
Yeah, you can leave. You may leave.
Thank you so much, sir.
Okay. So whenever you're getting it, whenever you are seeing this feedback, if you are answering all the questions that are there, starting from about the workshop, then about the trainers and the teaching, about the workshop again, then workshop assessment, administrative support, everything, overall rating, if you're doing it, then you can see it. You can see it. Try it at some other time, at your end. Maybe tonight you can give it a try.
So when I log in into my Atal portal and when I'm clicking on FDP, there is no FDP. Sorry, no feedback is available. This
I'm
is
telling
what.
you, I'm telling you, on the left hand side, just below the participant, then your mail ID, then general details, profile, FDPs, applied FDPs, attendance, assessment, then feedback.
Yep. Okay,
Click
got
on
it.
the feedback, then you will get multiple FDPs that you have done till now, right?
Hmm.
And out
Okay,
of them,
got
one
it.
is You just need to search this one. How you can search it is the end date is August 30th. So you can see it
Oh,
there.
yes, sir. I got it. I got it. Thank you very much, sir.
Okay. Bas.
हेलो सर। हेलो
Yes, sir. Yes, sir.
सर, मैंने तो टेस्ट दे दिया, उसके बाद फीडबैक कहाँ देना पड़ेगा?
सर आप अटल पोर्टल में जाएंगे ना, ये आज भी कर सकते हैं या रात को कर सकते हैं आप। अटल पोर्टल में जाने के बाद लेफ्ट हैंड साइड में नीचे आपको एक टैब दिखेगा, दैट इज अ फीडबैक वन। वहां जाने के बाद आपको ये एफडीपी दिखेगा, उसमें रेड कलर का एक बना हुआ रहेगा, उसमें क्लिक करेंगे तो एफडीपी का फीडबैक पोर्टल खुल जाएगा। वहां पे कई सारे क्वेश्चंस हैं, अराउंड 15-20 क्वेश्चंस हैं। आपको यू हैव टू रेट इट ऑन अ स्केल ऑफ 1 to 5 एंड वन क्वेश्चन इज देयर वेयर यू हैव टू रेट इट ऑन अ स्केल ऑफ 1 to 6। करने के बाद सारे जो हमारे स्पीकर्स थे उनको भी रेट आउट करने के बाद सबमिट फीडबैक कर देंगे, हो जाएगा। जब तक आप उसको नहीं करेंगे आपको वो दिखेगा नहीं।
अच्छा, ये तो मैंने दे दिया एग्जाम। एग्जाम मैंने दे दिया।
बस।
तो उसको 12 बजे तक दे सकते हैं?
हाँ, आराम से कल सुबह तक
ना,
कर दीजिए।
या कल कल कर सकते हैं क्या?
कल मॉर्निंग पे। अगर आप उसको नहीं करेंगे तो आप सर्टिफिकेट नहीं देख पाएंगे मंडे, ट्यूसडे, वेडनेसडे जब भी हम इसको यहाँ से रिलीज करेंगे।
अच्छा, तो वो मैं रात तक कर लूंगा उसको। ओके, थैंक यू सर।
अभी थोड़ा सा ट्रैफिक हाई है तो इसको आप बाद में भी कर सकते हैं थोड़ा सा।
ओके ओके सर, थैंक यू।
बट भूलिएगा मत।
Sir, I finished the test and I given the feedback in Atal portal.
Okay, ma'am.
Can I leave?
Yeah, ma'am. Yeah, please.
Thank you so much.
हाँ, सी अटल पोर्टल में अभी लिया भी जा रहा है। देखिए काम तो हो रहा है, वहां पर चल तो रहा है। आपके एंड में अगर नहीं हो रहा है, आप बाद में एक बार ट्राई कर लीजिए।
Sir, हो रहा है, but due to the, as you
Now it
mentioned,
is
that for the network traffic, it is
active.
taking some time.
हाँ,
But
it
it
is
is
taking
working.
right.
Thank you very much,
Yes,
sir.
sir, it is
Okay,
active.
madam. Okay, thank you so
Thank you,
much.
sir.
Sir? Hello?
Yes, ma'am. Yes, ma'am.
Yes, sir. I've done with my test, but the Atal FDP is not opening actually. It is
No
showing
issue.
502 bad gateway.
No issues. You just try it at around, let's say, at night or tomorrow morning. Huh? It will work.
Okay. Okay,
Maybe
sir.
due to the rush hours, it's not working right now. So it will work. Don't worry. Be there at early morning hours. Please do fill the feedback there. Then only you'll be getting your certificate.
Sir, it opened. I'll just quickly do it.
Okay, fine. Thank you.
Okay, thank you, sir.
Okay, thank you.
Thank you. Bye.
Sir, I'm able to open that Atal, but that feedback form is not showing here.
It will show, ma'am. You check out the left-hand side portal, huh? Where
Sir, I
participant is
checked.
written.
Sir, I checked. I entered also, but then last when I was submitting it, then it's not working properly.
Aha, that's why you tried later at night or early in the morning hours, huh? That time the rush
Okay,
will
sir.
be
There's no
lower.
problem, no? There's no problem. No? It's not
No
showing
problem.
now.
See, let me tell you. Until and unless you put the feedback, AICTE will not release the certificate on Monday, Tuesday, Wednesday, Thursday, latest by Friday or Saturday, you'll be getting it. Until and
Yes,
unless you
sir.
do it, you will not be getting the certificate. They will not release it.
That's yeah. That's why I was trying, but it is not properly
Do it
opening.
tomorrow morning. Do it tomorrow morning. Thank you.
Okay, sir. Thank you.
Hello, sir.
Yeah,
I
ma'am.
completed my feedback and test both. Should I leave?
Yeah, you may. Thank you.
Thank you, sir.
Hello, sir.
Yeah, ma'am.
Sir, my quiz is completed and feedback also done.
On the Atal portal also, right?
Yes, Atal portal.
Fine, done. You may leave.
Okay. Should I leave?
Yeah, ma'am. You can.
Okay. Thank you very much, sir.
Thanks.
Sir, today only one attendance link was filled, no? Feedback
Yeah,
link.
only one
Or
attendance and feedback is there. Rest all through our this Google Meet automated attendance recording system is there. We'll be having it from there.
okay, okay. So only one I have submitted attendance.
Fine,
Okay.
only one, and you have to submit the feedback on the Atal's portal also. You have to give the
Okay.
test. That's it.
Okay. Okay.
Actually,
Thank
is there anyone who has given the test on Atal portal? Is there anyone out here?
I think no, sir. Okay. Okay,
None.
sir.
Okay, fine. No
Okay.
issues. Okay.
Sir, if you could kindly tell me the process of giving the feedback actually. I have logged in into my account,
Fine.
and there I have in the left hand side I have an option feedback, right?
Right. Yeah, it is there. You can see the general details, profile, FDP, applied FDPs, attendance, assessment.
Yes, sir, I've got it. So under
Just the
that,
assessment feedback is there. Yeah.
yeah, submit feedback. Okay, red button. Yeah, okay, sir. Okay, sir.
Yes,
Yeah,
yes, yes. Search out your FDP, this FDP, click on the red button, the portal will open up, and then give an answer to the all the
okay, sir.
give us the
Okay.
rating, huh? Give us the rating.
Uh, Hello, sir. Good evening.
Yeah, sir. Please.
Sir, I have completed the quiz and also I have submitted the form.
Fine, done. On the Atal portal also, right?
Yes, sir.
Fine, then so.
And right now I can log out now?
Yes, you can log.
Okay. Thank you very much, sir.
Yeah. If you're from ITM SLS Vadodara, anyone right now?
Hello, sir.
Yeah,
So
Ajay
I have
sir.
given also test also and feedback in Atal portal.
Okay. If it is done, you may leave.
Yes, thank you so much, sir. And it's very good session. Amazing.
Thanks a lot.
Yes, thank you so much, sir. I will contact you. I'm a assistant professor in NMIT college right now.
Okay.
Yes, in
Okay.
Pune, Talegaon, Dabade.
अच्छा.
Yes.
You can definitely contact me anytime.
Yes, and also I'm a PhD research scholar in
Where?
Symbiosis University.
Where have you
Symbiosis
registered?
International University.
Where?
Symbiosis University.
Acha, Symbiosis. At Symbiosis. Fine, fine.
Yes,
Great.
yes, yes, yes.
Be in touch. Be in touch with us.
Yes, I will contact you, sir.
Definitely.
Definitely,
Anytime.
sir. For
Anytime.
helping, please help me for my PhD topics.
Anytime.
Yes. Thank you so much, sir. Thank you.
Sir, done the quiz, and whatever the portal has been, not in portal feedback, the this thing in the WhatsApp group we had a feedback that I have filled. Portal feedback will be filling on Monday, sir.
Okay, okay, ma'am. Done, done. It's okay.
Done the test. Okay, sir. Thank you so much. Thank you.
I got it.
Sir, I'm done with the feedback process, sir. Thank you so much. Can I leave, sir?
जी sir. जी sir. जी sir. कर दो. Yeah, ma'am. You may leave now. You may
Okay,
leave.
sir. Okay, sir. Sir, you kindly take rest, sir. You were continuously putting effort in this entire FDP, so you also need rest, sir. Okay, sir.
अच्छा, Sagarika ma'am, are you from West Bengal?
Yes, sir. Yes, sir.
अच्छा, which place in West Bengal?
Sir, I'm basically from Northeast,
Okay.
from Agartala, Tripura. But then I did my bachelor's and my master's in Kolkata only. And then
अच्छा,
later I got like into first of all I got into Techno India, and then I started working in a government college. And later on, after I left that and came in Tamil Nadu. It's been like 1 month here. So
okay, okay.
I've been here working as an assistant professor. So it's been just 1 month. This 4th of August it will be 1 month, sir.
अच्छा, you are in the department of CSE only.
No, sir, I'm in IT here. So basically, the
Yeah, yeah.
CC department is too big out here.
Okay, okay.
So it has like a cluster of departments.
Mm-hmm.
And I didn't want to join any other department. Hence, sir,
No,
IT.
it's okay. It's okay.
Yeah.
তো বাঙালি তার মানে, তাই তো?
Yes, sir, of course, Bangali.
ভালো লাগলো বাবা, খুব ভালো লাগলো। আমার বাড়ি দুর্গাপুরে, ওয়েস্ট
আচ্ছা
বেঙ্গল।
আচ্ছা 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 স্যার।
হ্যাঁ, আমার পুরো পড়াশোনা ওখান থেকে বিআইটি মেসরা এনআইটি দুর্গাপুর, এই দুটো জায়গা থেকে।
আচ্ছা আচ্ছা স্যার। আচ্ছা
এখন
এই
আমি জেপিতে আছি।
আচ্ছা আচ্ছা স্যার। আপ মানে মহারাষ্ট্রতে স্যার না মধ্যপ্রদেশ?
মধ্যপ্রদেশে, মধ্যপ্রদেশ, মধ্যপ্রদেশ,
মধ্যপ্রদেশ।
পুনা। এটা হচ্ছে ভোপালের কাছে।
আচ্ছা আচ্ছা আচ্ছা, বুঝলাম বুঝলাম।
হ্যাঁ, এটা ভোপাল।
Sir, I'll get in touch with you regarding any
হ্যাঁ,
kind
হ্যাঁ।
of queries
কোনো
I
আমার
have.
পিএইচডি তে রেজিস্ট্রেশন করেছেন কোথাও?
হ্যাঁ, I am registered actually, but my this thing got over, coursework got over.
গ্রেট।
Kolkata only, sir.
ফ্রম হুইচ কলেজ?
আমার
ডব্লিউবিউটি?
না, আমার গাইড হচ্ছে আলিয়া ইউনিভার্সিটি।
আচ্ছা, আলিয়া। হ্যাঁ, হ্যাঁ, জানি।
So currently working in it, but coping up with all the work, sir. I am also still in college right now. চারিদিক অন্ধকার হয়ে গেছে। I'm sitting in my
আরে
cabin.
আমার আমার অবস্থা এই দ্যাট আমি এটাও দেখছি, আমার আন্ডারে একটা পোস্ট ডক আছে, 3জন পিএইচডি আছে, আমি ওয়ার্ডেনও হচ্ছি, আমি নোডাল অফিসারও হচ্ছি মিনিস্ট্রির, আমি এটাও করাই। মানে যতটা সম্ভব হয় নিজের মাথাটাকে আমি বিজি রাখি, যাতে করে ঘরে গিয়ে না আমি শুই না, আমি পড়ে যাই বিছানাতে দাঁড়াও।
True, sir. True.
একদম একটু মেসে খাই, গিয়ে খেয়ে দিয়ে শুয়ে পড়ি। আমার মা বাবা থাকেন দুর্গাপুরে।
আচ্ছা 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 আচ্ছা।
যাক, ভালো লাগলো একজন বাঙালিকে তো দেখতে পেলাম।
ঠিক আছে স্যার, we'll
হ্যাঁ,
get in touch with you, sir.
একদম একদম। চল, গুড নাইট।
Thank you, sir. Bye, sir. Bye, sir.
Sir, done with the test and the feedback on Atal FDP.
Are great. If so Atal is also working fine, right?
Yeah. I just finished up with the feedback also.
See, gradually in the next 1 hour it will be very nice. I mean, by the way, you don't have to panic. You can do it in the next 2 days also, 3 days also, the feedback, because we'll also process a lot of things.
Yeah.
Okay? So don't worry.
Yes, so thank you very much. And surely I'll be in touch.
Please be in touch.
Yeah, sure, sir. Thanks a lot.
Okay. Great.
Shall I leave, sir?
Yeah, you can. You can. Have your dinner now.
Yeah. Thanks a lot. You also take the dinner, sir.
Yeah. I'll also.
Yeah, sure.
Be closing the test in the next 2 to 3 minutes of time. रानू मैम क्विज हो गया? हिमांशु जी इट्स ओके, अगर एरर आ रहा है ना अभी तो आप रुक जाओ कुछ देर, तो फिर कुछ देर बाद सही हो जाएगा, रात को सही हो जाएगा.
Hello, sir. This is Siddharth, and I have submitted through the WhatsApp link, and it is not mandatory to solve through the Atal portal. If
No,
I
you
solve
have,
through
no, you don't have to solve it there. I mean, no quiz there, but the FDP you have to submit there again.
So we have to submit FDP from there, Atal portal.
Sorry. Feedback there.
The
Test.
feedback
Tell me.
Feedback also submitted na through WhatsApp
Okay,
link.
The feedback on the Atal portal is done?
No, not Atal portal. Through WhatsApp link I have submitted on daily basis.
Even on the Atal portal also.
Okay.
No. Log into the Atal portal, keep it there also.
It is showing no feedback available.
No feedback. Feedback is available.
It is showing the Atal portal is no feedback available. I am going.
Feedback is 100% available, sir.
I can show you my laptop.
Sir, feedback is not available on Atal portal. I am also facing same issue.
है, आ जाएगा. अभी थोड़ा सा रश आवर्स है, आप थोड़ा टेंशन ना लें, आ जाएगा एक आध घंटे.
On Atal portal it is showing the exam conducted after 7:50.
ना एग्जाम को क्यों देख रहे हैं आप बात करो फीडबैक का, देख रहे हो एग्जाम को, आप फीडबैक के टैब को क्लिक करें. फीडबैक FEEDBAC के फीडबैक को देखिए आप.
Yes sir, same feedback पे मैं क्लिक कर रहा हूँ, but I didn't get the actual form.
हाँ, तो उसको क्या बता क्या रहा है जब आप क्लिक कर रहे हैं तो?
No feedback available.
ठीक है, उसको एक आध घंटे बाद ट्राई करें. ठीक है,
श्योर सर, हो जाएगा ना?
आ रहा 100% होगा. अभी क्या हो रहा है ना, ये टाइम स्लॉट कॉमन है फॉर 53 to 55 अदर FDPs पूरे भारत में चल रहा है अभी.
ओके सर, ओके.
तो सारे लोग इसी वेबसाइट पे हिट कर रहे हैं.
तो सर जैसे अगर आज कर दिया ठीक है, अगर नहीं हो पाया एक घंटे बाद भी, तो देन व्हाट वी डू?
कोई इशू नहीं है, कल सुबह कीजिए, परसों कीजिए, लेकिन मंगलवार तक तो कर दीजिए साहब.
श्योर सर, श्योर. थैंक यू सर.
बस आप अगर नहीं करेंगे ना तो जो मेहनत हम इधर करके रखेंगे उसके बाद भी आपको सर्टिफिकेट दिखेगा नहीं जब तक आप उसको भरेंगे नहीं.
ओके सर, ओके.
ठीक है सर, चलिए ठीक.
When we got FDP certificate, sir? When we will get?
There are 3 things to be done. आपको फीडबैक भरना है, आपको उसका टेस्ट देना है, आपके पास 80% अटेंडेंस होना है, 80% मार्क्स होने, 70% अटेंडेंस होने हैं. ये सारी चीजें होनी है, प्लस हमें आपका नंबर चढ़ाना है एंड आपके अटेंडेंस को चढ़ा देना है, और आप फीडबैक भर देंगे अटल पोर्टल में. जैसे ही हो जाएगा आपके पास जनरेट हो जाएगा ऑटोमेटिकली.
Attendance we have checked on FDP portal. It is showing 100%, and more than 80%, 90% I have solved it.
बाय डिफॉल्ट दिखा रहा है. हम लोग फिर से एक बार पूरे चीज को रिव्यू करेंगे.
Okay, I am daily present, na? That's why it is not problem.
हाँ ठीक है, प्रेजेंट है डेफिनेटली रहेगा, नहीं है तो एक आध एब्सेंट हो जाएगा. चिंता ना करें.
It doesn't make any difference.
अरे मैं चाहता हूँ आप सबको मिले साहब, आप सबको. ठीक है.
So can I leave?
हाँ एकदम पंच साहब ठीक है.
Brender sir is my roommate.
हाँ कौन?
Dr. Brender Patel.
अच्छा, पटेल के रूममेट हो आप? ठीक ठीक ठीक, आप लोग खाना वाना खाइए अब जा करके, ठीक है?
ओके ओके सर, ओके।
सर
हाँ जी,
थैंक यू।
कौन है जरा बताइए तो। अच्छा, आकाश।
यस सर, थैंक यू। फोरेंसिक के डोमेन के होने के बाद भी आपने मुझे प्रोवाइड की। मैंने सारे सेशन सुने हैं सर,
कमाल
सब
कमाल।
पूरा एक्टिव था।
हाँ
मेरे लिए
हाँ।
काफी चीजें न्यू थी, और मतलब पूरी चीजें न्यू है। और पढ़ा हूँ सर, इसकी पीपीटी चाहिए मुझे।
सब
और
मिल
सर एक
जाएगा।
आएगा मेरे फॉरेंसिक एस्पेक्ट से भी, अगर मैं देख रहा था इस चीज को कि कहाँ
हाँ
मैं आगे मैं ला सकता हूँ इसे, और
हाँ
अपने पीएचडी कहाँ हेल्प ले सकता हूँ इसे।
हाँ,
थैंक यू सर, अमेजिंग सेशन था।
हाँ। मेघा भर दिए? मेघा फीडबैक भरे?
Sir, doing that only.
अच्छा, करो करो, अटल पोर्टल में भर देना है ना?
हाँ जी सर, doing that only. वो भर रहा है सर अभी।
अच्छा
सर मेरे को लिंक दे दो ना, लिंक नहीं मिली। कंप्लीट हो गया सर। सर अटल पोर्टल पे भी लिंक अपडेट हो गया सर। थैंक यू सर।
हाँ हाँ हाँ
ओके सर।
हाँ
मैंने
ना, अटल में आप क्विज मत दीजिए अटल पे, अगर इधर दे चुके हैं ना तो उधर अब मत दीजिए।
हाँ नहीं नहीं दे रहा हूँ सर, मैंने वो क्विज यहाँ पे दिया और एफडीपी का फीडबैक अटल पे पोस्ट कर दिया है।
बस बस, आप धीरे धीरे ना हर 10-15 मिनट में वेबसाइट बहुत अच्छे से चलने लगेगा, क्योंकि रश अभी धीरे धीरे घट जाए।
श्योर सर,
वरुण,
श्योर सर, थैंक यू।
जी सर, जी सर।
मैं आई लीव नाउ सर। मैं
सर मुझे लिंक दे दीजिए ना, अटल वाली लिंक नहीं मिल रही मुझे।
अच्छा, अटल नहीं दिख रहा है, रुक जरूर मैं दिखा रहा हूँ,
हाँ।
अभी दिख। अटल वाली लिंक, ये चैट दिख रहा है, चैट से लेगा या फिर इसमें डाल दूं व्हाट्सएप में?
सर ये
सर मिल गया, मिल गया, मिल गया, मिल गया, मिल गया।
चैट बॉक्स पे डाल दिया सर, देख लीजिए।
ठीक है, थैंक यू सर।
मैं आई लीव नाउ सर।
हाँ हाँ,
ओके सर, थैंक यू सर, हैव अ नाइस डे सर, गुड डे, गुड नाइट, स्वीट ड्रीम, टेक केयर।
गुड नाइट, थैंक्स।
ऐड कर। ये नहीं है। हाँ सर, नहीं कर रही काम, वो कुछ इशू आ रहा है।
क्या इश्यू आ रहा है?
सर वो एरर बता रहा है।
कहाँ पर? फीडबैक में क्लिक करने के बाद?
वो डायरेक्ट उसने लॉगिन पेज पे भेज दिया मेरे को, फ्रंट पेज पे, तो वहां पर अंदर जाके फिर लिंक खुलेगी क्या?
हाँ, बस इसमें लॉगिन जो बना हुआ है ना भाई,
जी
देखो
जी
ईमेल और पासवर्ड डालने को बोल रहा है, वहां पे जो आपका रजिस्टर आईडी है उससे ईमेल और पासवर्ड डाल दो, और फिर नीचे कैप्चा डाल दो, ये
जी
7 कैरेक्टर वाला। अंदर
जी
घुस
सर।
जाओगे तो लेफ्ट हैंड साइड में आपको दिखने लगेगा फीडबैक का टैब। अरे मेगा, थोड़ा समझा देना।
जी सर, मैं मेगा दी समझ लेता हूँ, रुकिए।
हाँ हाँ
मैं कॉल करके समझाती हूँ सर।
हाँ
ओके, थैंक यू।
Excuse me, sir, I have one doubt.
Yeah, ma'am.
Sir, I completed the Google form which you have sent in WhatsApp, but in Atal portal the marks have not displayed. Will it be displayed or?
It will be displayed. It will take 2 to 3 days of time.
Okay, sir, thank you.
We'll do it manually out there. Huh?
Thank you, sir.
Okay. So I'm closing this session. Thank you, everyone.
Thank you, sir.
Thanks, man.
Thank you, sir, for arranging such a wonderful FDP.
Thank you. Thank you.
Hello, sir. Hello, sir. Hello, sir. Sir, I am unable to log in on portal, so I can't fill feedback form.
Hello. Is there someone who is talking to me? Nana, it's okay. Be there. Aditya. You all are my team. Come, come, come. Ab kaun bachayega. Is there anyone who was talking to us? Sorry, I couldn't respond then. I was shifting my panel. Yeah. Please, is there anyone? बस अब done. We are shutting it off. Save करना है.